Good evening, good evening, good evening, my dearest NEET warriors. Let me just refresh that comment screen. Yes, so now I can see myself. That means you can see me too. So, very good evening to each and every one of you. 21st of June is not much far, my dearest NEET warriors, and yes, because of that, we have to be on our top performance, and in order to help you for your chemistry preparations as promised, beta, we have covered logically and theoretically and practice wise also the complete chemistry during our previous live. And from this live, what is our intention to do? Beta, we will be revising all the relevant concepts, all the high probable topics, and today, as you can obviously see, we'll be revising. But how revising, sir? The most probable topics. Sir, what chapters you have brought us? What high probable chapters you have brought us for today? Beta, first we'll be starting with the basics of physical chemistry. Then with atomic structure, we'll again be moving to the inorganic side of important questions. Yes, for today I have specially selected practical organic chemistry, inorganic chemistry also, salt analysis, because beta, I have a feeling, yes, your NEET examination, because JEE Mains also has inducted salt analysis very beautifully, because that also helps them to ask regarding the P block logic as well, having direct relationship with chemical bonding. And yes, after that we will be having more in-depth discussion through PYQs, through the relevant questions on the most famous chapter of organic chemistry, which is carbonyl compounds. So last we will be dealing with aldehyde, ketones and carboxylic acid. But how? We will be doing the most probable questions, because most of you fear that chapter because of so many reactions in that organic chemistry chapter. So we will be ending the session with carbonyl compounds by learning all the theory. But how theory, sir? Through questions. So this is going to be a power-packed session, and I hope everybody is ready with the pen and copy. So let me just read those comments. Okay, acha. So Ananya, acha. Let me just make the comment screen a bit. Please help. Please allow me, beta. Yes, now I can see those comments. And now I can see those names as well. So, good evening, Ananya. Good evening, Unknown. Good evening, everybody. Chalo. So, let's start. Is everybody ready to solve chemistry PYQs, the relevant PYQs with me? And yes, not only solve, sir, we'll learn the theory as well. So let's start the process. So we will be starting with the first question, a basic question from mole concept. So let's try to attempt this one. I hope you are reading the question, and I will be giving you 45 seconds to attempt this, and your time starts now. Chalo, quick everybody. Yes, Jai Shri Ram, Gagan. Yes, देबाशीष, कितने बजे तक क्लास होगा? बेटा, it will be somewhere around maybe around 12, beta. Your smile is refreshing, sir. Rahul, thank you. Sir, Jai Shri Ram. Gagan, Shukla ji, Jai Shri Ram. D. Everybody is replying D. Why D? Because beta, obviously, perfect. Radhe Radhe, sir. Radhe Radhe, beta. Chalo, let's start. Now, what we have here, sir, we have a mixture of 2.3 gram of formic acid and 4.5 gram of oxalic acid. It is treated with concentrated sulfuric acid, which is a dehydrating agent. So, formic acid, which is HCOOH, will react with this dehydrating agent, which is concentrated sulfuric acid, and obviously dehydrating agent will remove water. What is left? So water gone. So even if you do not know the inorganic chemistry, the basic formula will tell you the answer. So remove H2O, so CO, carbon monoxide, is produced. Once you have a COOH and COOH as an oxalic acid, which is H2C2O4, with dehydrating agent, definitely sir you get CO2, you get dehydrated as in water, so water formed. Then sir, even if beta inorganically you do not know the reaction, still you can predict that using the stoichiometry, using just the molecular formula. That means sir, 1 mole of this will create 1 mole of carbon monoxide gas. Sir, 1 mole of this will create 1 mole of carbon monoxide also and 1 mole of CO2 also. Now, because I'm using 2.3 gram, so what is its molecular mass, sir? I hope everybody can see and calculate. For formic acid, I guess molecular mass is 46, I guess. Just check beta. Yes. So if it is 46, then that means this is the number of moles for formic acid. Let's say it is N1. It will be 1 by 20. Similarly, let us calculate moles for oxalic acid N2. Sir, it will be given weight which is 4.5 and I guess its molecular mass is 90. Just check everybody. I guess this will be 1 by 20 in that case. So that means moles of both are same. So same moles of carbon monoxide and CO2 is produced, but the question is telling you the evolved gases, which are these, are passed through KOH. And we should know this, that KOH being a base will neutralize the acidic oxide. So ultimately CO2 will be gone from the mixture. So you will be only having N1 moles of CO and N2 moles of CO. So total moles of carbon monoxide that you will be having, the total moles will be N1 plus N2. That means 1 by 20 plus 1 by 20, that is 2 by 20, that is 1 by 10 moles. So what will be weight of carbon monoxide? Sir, moles into molecular mass. Moles is definitely 1 by 20 and molecular mass of carbon monoxide is 12 and 16, that is 28. So practically your answer is quite easy and doable, but yes, rather a very conceptual question. And yes, so we have 100% students answering this one. I am very proud of each and every one of you, which brings us to the next one, beta. Yes, so I am again giving you 45 seconds to attempt this. We will just refresh our mind and our pen with some basic questions of physical chemistry, and then we are definitely rushing to that area with which we will be trying to learn something. I hope everybody is clear. Guys, I hope everybody is clear. Okay, Karthik, perfect. Okay, Hari Priya. Then we have Harshit. So, okay, cool. B, A. Gagan is saying A. Shivanshi is saying 1. Ananya is saying B. Laksh is saying B. Okay, so we have students. Yes, good evening, Madhav. Very good evening, my dear NEET warrior. Chalo beta, let's see. Now, the question is saying, let me see how many of you have got this one. So it is A, percentage is less. Let me check whether it is A or not, because I guess the percentage is very, I guess it is A only. Let's check. Now you have to give the minimum number of molecules. Okay, the number of molecules of water is maximum. So sir, number of moles calculate. If moles maximum, number of molecules will also be maximum. So number of moles, 18 ml of water, sir. Beta, water has density 1 gram per ml. That means this is 18 gram of water, because density of water is 1 gram per ml. So I can say it is 18 gram, and 18 gram of water means number of moles of water is 1. So molecules will be 6 into 10 is 23, quite large. Obviously, sir, this weight is less, so this will lose. So this is not even 1 mole, so this will lose. These many liters of water vapors at STP. So because this condition is STP, so I can do number of moles is equal to volume occupied, which is 22.4 into 10 raised to the power minus 4 upon molar volume is 22.4. So these moles are even lesser, sir. So obviously, beta, a very doable question, but I do not know why the percentage is less. It was less, but I hope it is clear now, guys, everybody. So this brings us to the next question. Yeah, quickly attempt this one, guys. Come on, quick. Quick, quick. Yes, right. Madhav is now saying right. B. Acha, I have not started poll for this question. So, because I have not started, so let me not start also. Let me read the question for you. I hope you guys attempted it. Suppose the element X and Y combine to form XY2 and X3Y2. 0.1 mole of XY2, as in the first compound, weighs 10 gram. So 0.1 mole 10 gram, then 1 mole will weigh, beta, that will be its molecular mass. So 1 mole, 1 by 10 mole is weighing 10 grams, so 1 will weigh 100 grams. So its molar mass is 100. That means, let's say if X is the molar mass, is the gram atomic mass, as in mass of 1 mole of atoms of X, and let's say for Y it is Y, so that means X plus 2Y is nothing but 100 gram, because I'm considering for 1 mole. Similarly, if these many moles of this weigh, then sir 1 will weigh, sir 9 upon 0.05, as in 900 by 5, as in 5 1 is 5, 5 8 is 40, then that means it is 180. I hope everybody is clear with this. Now, sir, if that is a case, then this means that 3x plus 2y is nothing but 180 rupees. So can I subtract? So if I subtract this from this, so 2y gone, 3x minus x is 2x, and 180 minus 100 is 80. That leaves us x to be 40. So because x is 40, so definitely we have got 3 as our answer. And because I have not given poll, I hope everybody got it. And similarly, then you can calculate y. Beta, these all are very refreshing and very probable question for your physical chemistry, which will also give a confidence to each and every one of you to actually how these common sense questions are generally asked in your NEET examination, and how can you be fast in attempting them by practicing more and more. So this is what we are doing, and I hope everybody is attempting. So talking about the next question, yes, Hasni is here, perfect beta. Gagan, yes sir, C. Madhav, perfect. Zahin, Rahul is saying clear, so perfect. Great guys, great. So I hope everybody is attempting this next one also. Let's see. The question says, yes, people are answering. So let us check. 1 mole of atom X has mass 0. This much times of mass of 1 mole atom of Y. That means gram atomic mass is given. So gram atomic mass of X is equal to 0.444 times gram atomic mass of Y. That is atomic mass. Atomic mass of X. Acha, okay, so this is gram atomic mass, because talking of 1 mole. So this is gram atomic mass of X and Y. The atomic mass of X is this many times mass of 1 mole of 1 atom of C12 isotope. Sir, if you remember the definition of relative atomic mass, then relative atomic mass is nothing but atomic mass upon 1 by 12 into mass of C12 isotope, and this denominator we refer as 1U, and it is saying that atomic mass of X, so atomic mass of X as in mass of 1 atom of X, is equal to 2.96 times mass of 1 atom. So if 1 by 12 into mass of 1 atom is U, then mass of 1 atom is definitely 12U. Hello? Mass of 1 atom of C12 is definitely 12U. That means I know atomic mass of X, which will be this much. So why solve here? Let us put it, I know atomic mass of X. So if atomic mass of X is this, which I know, what will be gram atomic mass? Sir, gram atomic mass of X will be, this is mass of 1 atom. So mass of 1 mole atom will be this value, which is 2.96 into 12 into U into Na, and we know Na into U is nothing but 1 gram. Na into U is nothing but 1 gram, because this is the significance of 1 mole. Mass of 1 mole of any species is nothing but the mass in gram, because multiplier becomes 1. So that means I know the gram atomic mass of X, which is 2.96 into 12 gram. Now what I need to find? I need to find atomic, as in atomic mass of Y. So let us calculate gram atomic mass of Y. Gram atomic mass of Y will be gram atomic mass of X, which is 2.96 into 12 gram upon this value, which is 0.444. But sir, this is mass of 1 mole. So mass of one species will be, sir, mass of one atom will be in U. And how we definitely know what is relationship between 1 gram and 1 U. Sir, if you divide by Na, so if I divide this by Avogadro's number, I will be getting my value. And definitely, sir, but this becomes very difficult to solve. Beta, if you just solve it, you will be getting somewhere around. Sir, it is not going to be cancelled very easily. So I guess if you just solve it, it is definitely going. Acha, it is coming 80, beta. I'm sorry. You have to solve it in that case. So let us solve it, because it is coming out to be 80 U. Let us solve this, everybody. Let us solve this, everybody, quickly. It is 2.96 multiplied by 16 divided by 0.44. It will come out to be 106. It will come out to be 106 upon Na. But this is in gram. I want in U. So definitely I know 1 U into 1 Na is nothing but 1 gram. So I have to know 1 gram upon 1 Na. That means 1 U is equal to 1 gram upon Na. So this will be nothing but U. But I guess this is coming out to be, okay, this is not coming out as we are expecting. It is not coming out 80. So we are doing some 106. Yes sir, 80 answer hai. Yes, even I can see that, beta. But let us see where we have gone wrong. Okay. Beta, this is 2.96 into 12. By mistake, I have written this 12 as 16. So first mistake is this. So I have to do 2.96 into 12. And then I have to divide this by 0.44, which will definitely give you 80. So my bad, instead of 16, instead of 12, I have written 16. And once you will solve, you will get 80. So my bad, here it was 2.96 into 12. And rather over there, I have written 2.96 into 16. So yes, my bad. And this is why we say, beta, you have to practice more and more. The more you practice, the more you end up not doing such mistakes. So we are teachers, we can obviously don't practice, we give everything for delivering the concept. So it is you who have to practice more and more. With that, let us move to the next question. Yeah, try this one, beta. Acha, let me see how many of you have got the correct answer for the previous one. Percentage is fair enough, beta. So let's try and attempt this one in 3, 2, 1. Quick, everybody, quick. Great start, no issues. Because ultimately these mistakes will tell us. That what we don't have to commit in the examination. Else, how will we knowing that what can take time? So these can take time. So you have to write your calculations very properly. Chalo, people are replying. I want to check. Okay. So Edids is saying 4. Then we have Shivanshi saying 4. Then we have Padmavati. Okay. Shankar. Chalo beta. I guess time is up. So let me see. Percentage is less beta. Only Astha, Edids and Jaydeep Bhai Patel. So Patel ji is right. Mole fraction of solvent in aqueous solution of NaOH having molality of 3 is. So molality is given. Molality is number of moles of solute upon weight of solvent in kg is given out to be 3. If I take 1 kg of solvent, sir, you can take any amount, but yes, now you have to do all the calculation for the amount of, for the concentration of, for the amount of solution you have taken, because concentration remains same whatever amount you take. So I've taken such an amount of solution where weight of solvent is 1 kg. Now I'll be doing all the calculation for this. Why, sir? Because now I know number of moles of solute. So I have 1 kg of water. So weight of water is 1 kg and 1 kg of water is having 3 moles of solute. Now I need to find mole fraction of solvent, which is nothing but water. Mole fraction of solvent is x1 will be number of moles of solvent upon total moles. So what is number of moles of solvent? 1 kg as in 1000 by 18 upon 1000 by 18. And what is number of moles of solute? So that I already know, 3. So if you just solve, now this is just a matter of into divide. Sir, but how there you have done into divide? Beta, into divide will take time. I agreed. That's why I brought you such questions which will help you to challenge yourself, because these are very probable questions for your examination. So kindly practice hard here so that you may not feel that heat in the D-Day. So once you solve, I guess most of you have got the answer. Coming to the chapter of solution and colligative properties, a very traditional question. So giving you very less time for this, 30 seconds. Kindly check beta. We definitely know. I want to get the right percentage. That's why I'm giving time also for this one, because guys, what happens is, we definitely know, sir, whenever you have these scuba divers, then deep down, the pressure of gas increases. And because pressure of gas increases, we definitely know, sir, because pressure of gas increases, as per Henry law, their pressure in our blood vessel will also increase. Oxygen, we have no issues, but air has maximum percentage of nitrogen, so it creates bends. A medical condition is arised. Once we come out, nitrogen comes with great amount, and therefore we get that medical condition which is bends, which is rather fatal. So in order to avoid this, what we do, sir, pressure will increase, so dissolution will also increase in bloodstream. So rather we can dilute the air tank. And how we do it? Sir, we do it by using inert gas. So 53% beta, this is exact NCERT data. 11.7% of helium you add. Obviously around 56% is nitrogen only, and this is my gas which I require for our respiratory system, for our biological system. So this becomes the correct composition which is there in NCERT. So a very important NCERT conclusion of Henry's law, which brings us to the next question. Your time of 45 seconds starts now. Sir, that means you have directly moved from mole concept and reached till after concentration term, we have reached to this chapter of solution and colligative properties. Quick beta, quick. Perfect. People are replying. Now, C, perfect. Sir, this is pressure of solution. Sir, we know at XB equal to 0, whatever pressure you have will be of pressure of the other component, which is pressure of A. So partial pressure of A will be 120, because if we put XB as 0, and rather if we put XB as 1, that means XA is 0. So whatever will be the pressure will be pressure of this will be in that case pure component A. and in that case, this will be pure component B. So what shall be pressure of B? Just put XB 1. So 120 minus 75. So 120 minus 75 as in 75 or 25 and 45. So these are my value of P naught A and P naught B. You have to tell the total vapor pressure, hence vapor pressure of OK. So you just have to give the value of P naught A. So this is 120 and P naught B, that is 45. So answer is definitely option 3. Let me check. 92%. You guys are rocking the charts. So perfect, guys. Perfect, everybody. I hope you can see the next question. Time starts in 3, 2, 1. Go. Shoot. Shoot. Perfect. Perfect. Everybody, great. I just get the water bottle refilled. Please ask someone for water. Please, I'll just come and take it. Yes, guys. So I have just asked for the water refill, and by the time I guess we have arrived to an answer. 100%, 100%. So obviously this is basically a question on the degree of ionization. So you should definitely know if observed molar mass of solutes, obviously you can calculate I, and once you calculate I, in case of dissociation it will be 1 plus n minus 1. So value of n will be 3 over here. So 3 minus 1 is 2 alpha, and therefore you can calculate alpha, which I guess everybody did perfectly. So let me, because it is 100%, so let me not solve it properly. I hope you got it. Perfect, 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 everybody. Chalo. Now let us begin the discussion with a basic fundamental beta. What is that basic fundamental beta? For your D block questions also and for your redox reactions questions also, one thing you should know. Sir, what we should know? Beta, balancing of a redox reaction. Sir, balancing of a redox can happen in acidic medium also and basic medium also. Rather, students find basic medium difficult. So let me give you another. Sir, oxidation number method beta, actually technically for your NEET examination 90% of the time it works, but beta RE-NEET doesn't happen 90% of the time. That's why I'm telling you, you should please at least know how to balance using ion electron method, that too in basic medium. So I'm going to balance it using ion electron method. How to do it? Let us try and learn this beta. I have KMnO4, I have permanganate ion, which is MnO4 minus in basic medium, which oxidizes to iodide ion. That means our first half will be MnO4 minus is reacting with I minus to produce iodine, and this permanganate ion is getting converted to MnO2. So we have to write the balanced half reaction in basic medium. How to do it? Sir, MnO4 minus is changing to MnO2. This is my first half. Now what we do then? Sir, balance manganese, it is already balanced. Now how to balance oxygen? Add water, because I have 2 oxygen, so I add 2 water. Oxygen balanced. Now in order to balance hydrogen, add H plus ion, but sir, medium is basic. Don't worry, because medium is basic, so add equal number of OH minus ions on both the sides. Once you do that, H plus and OH minus ion will remain associated as water. Then you will definitely have to simplify water. So this water has got cancelled, and now balance charge. This is having -4 charge. This is having -1 charge. So I will add 3 electrons, which means this is the reduction half. So first half is balanced. Now let us balance the other half. Sir, other half is I minus is getting to I2, which is quite easy because there is no oxygen and hydrogen. So I just balance charge. Now after that, sir, you have to equate electron transfer. So this equation has 3 electrons, so multiply this equation by 2. This equation has 2 electrons, so multiply this by its coefficient, which is 3, and then you should add the reaction. So let me add the reaction and write over here. So 2 multiplied by MnO4 minus. So this gives you twice of MnO4 minus. 6 electrons gone, but I'll be having 2 into 2 as in 4 water molecules. What else, sir? 3 into 2 as in 6 times of I minus. This will give me what? Let us write the products also, beta. It gives me twice of MnO2. So, sir, twice of MnO2. What else? Sir, water is cancelled. So, this is 2 and 4. That means 8 times of OH minus. And what else, sir? Then I have 3 times of I2. So, beta, rather, this will give you the balanced reaction, and beta, sometimes oxidation number method may disturb you. But ion electron method, never. It always gives the correct answer. But yes, I agree, it takes time. I agree, it takes time. Doing by oxidation number method rather is a one-line thing. But beta, sometimes, and RE-NEET doesn't happen all the time. So, just keep yourself updated with the ion electron method, which brings us to the next problem. Yes. So, moving to the another more famous side of physical chemistry, which is atomic structure. So, few questions from atomic structure. Time starts in 3, 2, 1, go. 45 seconds for this one. Although I guess this question is quite doable, but still, because you have to read theory. So, kindly try and do this one, guys. Quick. By the time, let me see the comment section. How are people enjoying? Sir, is my message visible? Yes, beta. But actually, I'm in a different studio, beta. So, the comment screen has a small font size of comment. So, by tomorrow or day after, I will be back in my home studio, and then we'll be having better communication. Chalo, people are answering. Perfect. People are answering. That's good to see. B. I guess time is also ending for the question. So, let's see. Answer is actually D for the question and 0%. So, let us have a discussion on this one, beta. The question says, which is true, obviously, you have to answer. So, charge to mass ratio of cathode ray generated by discharge tube of different gases are different. No, sir, it is same, because every gas is going to produce electron, and the electron is just the same particle, which is E. So, even if hydrogen creates electron, it is electron. Even if oxygen creates electron after getting ionized, beta, electron moving away from cathode towards the anode will have same charge to mass ratio. So, this is definitely incorrect. Yes, what will be charge to mass ratio of the positive ions will be different, because hydrogen will have H plus, helium will be He2 plus. Either it is He plus, charge is +1, but mass of the nucleus is different. So, E by M ratio of anode rays will definitely change as you change the temperature, but here it is saying it is same. So, that's why this is also incorrect. Now, obviously, E by M ratio of protons, so charge by magnitude on electron proton is same. And because, sir, mass of proton is more, that means this denominator will be less. It is saying opposite, so this is also incorrect. And obviously, charge on proton is plus E, charge on alpha particle is plus 2E, so I have a factor of 2. Mass of proton is, let's say, M. Mass of alpha particle, sir, alpha particle has 2 proton, and so this is 4 times of M. So, this is 1 by 2. So, definitely this is 1 and this is half, which is lesser. So, option 4 is right, my friends. So, yes, rather a easy looking but a very probable English doing question because that was nothing but, yes, reading English and being confident about the logic. So, I hope you got it. Moving to the next one. Quick, please read, beta. समझ गए, okay. Perfect. Okay, no worries. Madhav is saying ये पढ़ने नहीं दे रहा. You, beta, then don't indulge in that discussions, na, Madhav. Focus on your exam. You feel every next person in your NEET examination will be helping you to perform. No, they will also be distracting you. So you have to work for yourself, na, beta. So, buddy, take care of yourself. Chalo. The question says the photon of light having wavelength 4000 are necessary to provide 1 joule of energy. Then sir, this is just basic. Let me see how many of you have done into divide, because yes, this is definitely into divide required. So perfect, 100% is correct. Now this is my wavelength beta in angstrom. So I know energy you can calculate in electron. How? Sir, 12,400 upon lambda in angstrom. So this is how you can calculate energy, but this is an electron volt and you have to give the photon of light having wave is necessary to provide how many photons. So this is the total energy. So number of this is a photon of light having wavelength theta are necessary to provide 1 joule of energy R. Okay. So total I need 1 joule of energy, and photon, each photon is having this much of photons of light having wavelength theta are necessary. So number we have to calculate. Total energy will be 1 joule. So total energy is 1 joule. Number of photons is n, and each having 12.4 by 4 as in 3.1. But this is an electron volt. So into 1.6 into 10 raised to the power minus 19 joule. So this will give you the value of n, which most of you have definitely selected correctly. It is option 2. Yes, so this is now just a matter of into divide beta, but yes, question was good. It is a basic one, but beta, you have to be confident with your multiplications, which most of you definitely are. So again, a graphical question, but giving you 30 seconds to attempt this. Time start now. Quick beta. The question is telling you, good evening, Sarika. Okay, perfect. Chalo, let's see the next question. The question says, which one of the following is incorrect? Sir, as you increase frequency, it should at least reach the threshold value, then only as frequency increase kinetic energy. So this is definitely correct. Correct, so not an answer because we are expected to give incorrect. Sir, as intensity increase, intensity depends upon number of incident photons. Yes, this is also correct, so not an answer. This is intensity and kinetic energy. No sir, intensity and kinetic. Intensity is just number of packets. It has nothing to do with kinetic energy. So definitely this is wrong, because it should be independent, it should be constant, but it is saying it is increasing, so that is incorrect. And obviously intensity and kinetic energy is independent. That means it should be a straight line. So this is correct and therefore not an answer, because we are supposed to give incorrect, which we have already given. Let me see how many have got this one. 66%. So fair enough. Moving to the next one. Now moving to the next one. Attempt guys, giving you again 30 seconds to attempt this one. In 3, 2, 1, go. Yes. Quick. Perfect. Zian is saying 1. Now Zian is saying 2. Now Zian is saying 3. And now Zian said 4. Very good. So Zian is giving all the answers. Very good, beta. Okay, people are replying 2, 2, 2, 2, 2. Let me check. Time done. So let's see. 70%. Perfect, beta. Let us quickly revise what the formula is saying. In hydrogen atom, if x is the radius of first orbit as in r naught into 1 square upon z, because this is n square by z. That means you know the value of r naught, because for hydrogen z is also 1. Then you have to give de Broglie wavelength of the electron in third orbit. So we know that circumference of Bohr orbit, which is 2 pi r, is nothing but n times of de Broglie's wavelength, which is lambda de Broglie. So what will be lambda de Broglie, sir? Sir, it will be 2 pi r upon n. So 2 pi r is r naught into n square. So third orbit, n square as in 3 square upon z for hydrogen is definitely 1, but I have this n in the denominator, so a 3 over here. So this 3 and 3 is gone. That means I'm having 6 pi r naught, and r naught is definitely x. So this is 6 pi x, which makes option 2 as a right answer, which most of you have attempted also correctly. Moving to next, chemical bonding basic. A beautiful question from chemical bonding. This is actually JEE 2025 question, a very basic question, but yes, rather a very probable one, because beta, statement based questions are actually asked because they check your reading ability also, and obviously your understanding of PCM, physics, chemistry, biology. So kindly attempt. Beta, Vashumathra. Vashunmathra. Beta, the name, I'm sorry, I cannot read properly. Beta, I am solving most probable questions. I have not restricted myself to any area. I have started with physical chemistry. Sir, what side of physical? I have discussed some basics of mole. I have discussed some basic of redox. I have discussed some basic of atomic structure, then solution and colligative properties. Because beta, those are the area, those are the questions which you definitely get question from. And exactly that topic I have discussed. And now I have moved to inorganic. Then I'll be moving to organic. But I will be picking things. Like for organic, I'll be more focusing on aldehyde ketones and carboxylic acids. In organic side of chemistry, I'll be browsing through chemical bonding main good questions, and then I'll be going to salt analysis. So this is how I have designed your class, because all the students who have come, maybe you want to learn something new, so it will be helpful for you also. If you have come to practice, it will helpful for you also. And definitely whatever concepts I have taken, whatever questions I have taken are high probable, because these concepts are JEE mains, JEE advanced. I mean, you will see through the slides that I have taken all the questions which are high probable logic, which NTA is going to ask in your NEET examination. Highly probable. Obviously, no one can give you the paper before the paper is given to you. Chalo. Moving to the discussion, which I feel. Chalo. So let's check how many of Bombay, I guess, is the answer. 83%. So fair enough, beta. Because obviously we can see statement 1 is correct. Why, sir? Because for ClF3 having 3 bond pair and 2 lone pairs, so steric number is 5. So it will definitely be a AB5, but 2 lone pair will probably should occupy equatorial position, which they are only occupying in structure 1. So this should be great. But it is saying that all 3, yes, they are possible. They may not exist in nature, but read the theory, yes, they are definitely possible. So this is true. Statement 2 says structure 3 is more stable. Sir, come on. Structure 3 is not at all stable, because you should go to equatorial position, because it is at an angle of 120 degree. Therefore, first is, so that this is definitely incorrect, which makes option 2 as your right answer. Which brings us to next question. Attempt this one, beta. Your 30 seconds I'm giving for this one. Time starts now. Quick. Rather again an attemptable one. Quick. 1. Option 3. One. Chalo, let's check. Time up. Obviously, answer is option A. Why, sir? 72%. So let's check the structure of PCl5 in solid state. Beta, once you become solid, actually molecular form of PCl5, if you have a PCl5 in gaseous state, its structure you know with VSEPR theory. Sir, it will be having 5 bond pairs, so trigonal bipyramidal. But once you have PCl5 in solid state, that means constituents are so close to each other, sir, they have to be an ionic compound. And how can it be an ionic compound? PCl5 molecule, sir, we definitely know out of the 3 equatorial bonds, the 2 bonds which are axial are having more bond length. And because this bond length is more, sir, so this chlorine can easily take these electrons, and if it do it, then it forms a PCl4 cation, phosphorus 1 electron gone, so it is tetrahedral, sir. And this Cl minus ion goes to another PCl5 molecule and add it up, because it obviously has empty d orbitals, or rather empty orbitals where it can expand its octet. So it will become PCl6 minus. That means bond pair is 6, so it makes an octahedral anion and a tetrahedral cation. And yes, now you answer me, if I have PBr5, again a very traditional question, but sir, bromine is very large. So 6 bromine, yes, the cation can obviously be formed here also in solid state. So it will be PBr4 plus. But sir, I am not saying PBr6 minus will not be formed. But yes, because it will be rather sterically hindered, so PBr5 will move apart and only Br minus stays as an ion. So this again a P block logic which you should know. But yes, you have given question for PCl5 which we already got. Now this was a good question to learn. Moving to a question from coordination compounds. Now again beta, see, now with this bonding I am asking you coordination compounds. So I am giving you high probable questions. Yes, but not only questions, giving you the logic also, so that you can learn also. I hope everybody is clear. Yes, perfect. Perfect Madhav. Perfect Exotic. Perfect Shivani, Ishu, Ananya, perfect everyone, great, perfect. D. Yes, definitely. Everybody know, sir, SCN minus is a weak field ligand. Therefore, this weak field ligand having coordination number 6 will bring no high splitting because field is very weak. So manganese in +2 state will be 3d5 with practically no splitting. So this will be T2G set, this will be EG set, and because the crystal field splitting is very less, because it is a weak field ligand, therefore I'll be having 1, 2, 3, then 4, 5. Then if you compare this with the Berry center, if you compare this with the Berry center, which is the average energy, so this is 0.6 times of delta naught, this is minus 0.4 times of delta naught. So how many electrons I have over here? 3. So 3 into 4 is 12. So this will be minus 1.2, and 6 into 2 is plus 1.2. So delta naught will be getting cancelled. So crystal field stabilization energy will be 0. Delta naught will be 0. And what about, because it is having, sir, 5 unpaired electrons, so magnetic moment will be, this mu due to unpaired electrons will be under root n into n plus 2 Bohr magneton, which is 5 in this case. So 5 into 7 is 35 under root, which is obviously closest to 6, less than 6. but close to 6. So 5.96 is my answer, which makes Delhi. I hope the percentage, yes, perfect, 100, almost 80%. So this is good. Everybody is doing great. Moving to the next one. Please read this one, beta. You do not have to learn all the colors. The chemical bonding and coordination basic can sometimes give you the trick. Yes, obviously, for understanding the colors, beta, the only job is to learn NCERT. But sir, it is very difficult for me to learn NCERT. Can I do it otherwise? Yes, you can. How? The question is in front of you. Please read. Please read. The question is in front of you. Please read. And I hope if you just read the question, you will be finding that why I am saying so, that if NCERT, through NCERT, you can definitely learn. But if you decide, if you are not having that desire or maybe that capability to remember, recall it, then still with common sense you can do the answer. How, sir? The correct set of ions in aqueous solution with same color. That means you should show color. So technically, in order to show color, you should be having unpaired electrons. Then that DD transaction can take place. So just see that how many of the options has species. Sir, what else? Give us the best. Beta, best process is obviously learn that D block table of the ions. Then only you should know. But I am giving you a predictability. A predictability of inorganic chemistry always exists. And if you just leave JEE Advanced, sometimes they ask that you should know that knowledge. Then only you can proceed forward. But that too they ask in a paragraph question. For a NEET or JEE mains level of examination, I am telling you, they will always give you a predictable question. So where does the prediction lies? Sir, Zn plus 2, sir, has no unpaired electrons. Sir, scandium plus 3 has no unpaired electrons. Sir, titanium plus 4, Shakti as in plus 4 will have no unpaired electrons. It will be like argon. So if they are having one species which is having no unpaired electrons, does it have a possibility to show color? No. All of them will definitely have unpaired electrons. Therefore, even if you do not know the color, you can give the answer, and let us see how many of them has done the common sense. 90%. So beta, great. Proud of you. Proud of everybody. Even those who have not attempted correctly, proud of them too, because from now they will be knowing what to do. Moving to the next one. Quick. Perfect. Perfect. Three. Now the question says stability of +1 oxidation state among boron family. Beta, please note that although deleted, but boron family is the most mischievous family. I have taken boron family in my inorganic session as well. Please do revise. Although that's why I've taken this one question, because this will directly drag you to the inorganic live, which I have done I guess on the previous. Beta, please check PW NEET English WhatsApp channel, PW NEET English YouTube channel. In WhatsApp channel, you'll be getting the notes. In YouTube channel, please, in the live section, whatever chemistry lives I have done, please religiously go over there and revise whatever content you want to. Do not do it just once. Keep on revising so that things remain here. And this is why I have brought just this question, so that I can force you to go and revise properly. If you remember, then perfectly. It is perfect. Sir, inert pair effect says that the stability of group oxidation state -2. So for group 13, group oxidation state is NS2 NP1. So group oxidation state should be +3. But sir, because of inert pair effect, these NS electron become inertial electron as you move down the group, and therefore group oxidation state -1, as in stability of +1 down the group, will increase. So stability of +1 down the group should increase, as in boron. It is not taken. So Baigan, Aloo, Gajar in Thela. So option 3 is definitely your right answer, which gives you C as your answer. which I guess my polling, I guess it has just hanged. Acha, we got, but I can't see it. I'm sorry. No worries. Let us move to the next question. Time starts in, again, beta. I'm not starting the poll here, although again, a perfect archive to remember, to revise inert pair effect. What does it say? Because of the instability of NS2 electrons of the valence shell to participate, sir, it is just asking inert pair effect. What happens? Sir, inert pair effects happens for the last element. So for carbon family, it will be Kashi, Ganesh, Shankar, Parvati, as in it will be for lead. So for lead, +2 will be most stable. So if lead is in +4 state, then sir, it will want to come to +2. So lead from +4 will want to reduce to +2. So if Pb +4 will reduce itself, that means it will oxidize others. So Pb +4 will be a better oxidizing agent. Perfect, sir. Sir, but inert pair effect is applicable for last element only. So not for tin. So that means for tin, sir, beta, for tin +4 will be more stable. So if rather you have tin in +2 state, then for +2 it will try to get in +4 state. That means it will try to oxidize itself. If it will oxidize itself, it will reduce others. So it will be a good reducing agent, and therefore beautifully a very good application of inert pair effect. 2 becomes your right answer, which brings you to this one. Time starts now. Please do read the question, and if you have doubt, hit the comment section. I'm reading those comments now. Quick. एक बार देख. अच्छा. Let me inert pair effect again. Okay. Let me just check that comment. Inert pair effect again. हाँ बेटा, inert pair effect again. Chalo, perfect. Which of the following ions does not liberate hydrogen gas? On reaction with dilute acid. The question is asking which does not. Mn+2. Yes. Why? D. Why, beta? Because, sir, if you just check manganese, then manganese in +2 oxidation state is having stable 3d5 configuration. Sir, half filled and fully filled configuration is stable. A, because of symmetry, and B, because of exchange energy. Because it can, how many exchanges it can have, beta? I hope that atomic structure logic you know. Sir, 1 can exchange with 2, 1 can exchange with 3, 1 can exchange with 4, 1 can exchange with 5. So this can have how many exchanges? 4. The second one can exchange with, so 2 can do with 3, 2 can do with 4, 2 can do with 5. That means it will have 3 exchanges. Third can have how many exchanges? 3 can exchange with 4, 3 can exchange with 5. So how many exchanges? 2 exchanges. Next, sir, let me use another pen, blue. So 4 can exchange with 1, so 1 exchange. So how total exchange, sir? 4 plus 3, 7, 7 plus 2, 9, 9 plus 1 is 10. So because it can have 10 exchanges, all these exchanges can release energy, and therefore these half filled and fully filled configuration are very stable. So why explain this, beta? Because this is there in atomic structure. You can expect a theory based question asking you the knowledge. That's why giving you every details also. So obviously, because Mn+2 is very stable, why will it try to change its oxidation state? It will not try. And therefore, if you have H plus ion waiting to release hydrogen gas, that means you want hydrogen to go from +1 to 0. That means you want hydrogen to reduce. That means these metals have to oxidize themselves. But why manganese in +2 state will try to change or alter its oxidation state, and therefore this guy will resist, which makes option 4 as your beautifully correct answer. I hope apart from these 75% students, you have got the logic also, and you should know how D block stability of oxidation state and electronic configuration helps to attempt better in your examination. Now, Beta, now with this question, I am moving to salt analysis. Why, sir? RE-NEET happens very less. And because it is happening, beta, NTA has got lot of attention in salt analysis in JEE examination. So I just want you to revise salt analysis directly through JEE mains question. Whatever data, whatever details through salt analysis we have, according to the latest questions, high probable questions, we will just understand and learn them for our better performance in salt analysis, because this will also help you to cater all those logics of P block elements and inorganic chemistry. So shall we start it? Sir, today's score, okay, perfect. Janish, chalo, let's start, beta. Perfect everybody. Great enthusiasm, guys. So let us quickly, let me remove this chair, because now we will not be doing poll and rather we will be practicing questions directly. Now, the first question says from salt analysis that I have a list 1 of anions and I have to compare it with list 2, the gas evolved when you have dilute H2SO4. So what is the logic? Sir, for anions, first you add dilute H2SO4. If the anion is creating any volatile substance like a gas, then that confirms primarily it confirms that yes, this anion could be there in your given salt. If not, you put concentrated acid. If not, that is then you do some separate analysis, separate anions, that is generally sulfate and phosphate. Now, what are the inferences, the common inferences that you should know? Sir, if you have carbonate ion, then carbonate ion from class 9th, 10th, we know it is a colorless gas. What is a colorless? Carbonate ion with acid produce CO2 gas, which is colorless. It is released with brisk effervescence. That voice that comes, that is called brisk effervescence, which turns lime water milky because of formation of calcium carbonate. A very famous point for carbonate ion, which with acid releases CO2 gas. That means A is 4. That means option A is incorrect, option B is incorrect. Now, coming to Bombay sulfide with acid forms H2S gas. Sir, H2S gas has a characteristic that it is also colorless, but sir, this gas turns lead acetate paper black. Why? Because of the formation of lead sulfide, PBS. Black PPT, again a very important characteristic of H2S. Now, coming to sulfite ion. Sir, if you talk of sulfite ion, then this sulfite ion with acid produces sulfur dioxide gas. And what is the characteristic of sulfur dioxide gas? It is also colorless gas. Now, it turns acidified potassium dichromate paper green. Again, this is a very famous, because sir, this is now D block involvement. Potassium dichromate is Cr2O72-, which is an oxidizing agent which oxidizes SO2 and oxidize this to sulfate ion. Because here sulfur oxidation state is +4, it is oxidized to +6, and chromium reduces itself in +3 state and exists as a sulfate. So this will be chromium sulfate. Chromium +3 appears a green colored compound. So again, a very beautiful and a very NCERT famous fact, beta. Now, NO2- is your nitrite ion, which with acid is released in form of nitrogen dioxide, NO2 gas, which is not colorless, which is a brown colored gas. And obviously this also turns Ki solution, it turns Ki solution containing starch blue. It turns Ki solution, because Ki solution which reacts and forms Ki forms I2, and I2 with starch paper makes it starch iodide paper, which you can see because it turns it into blue color. So very important, beta, inorganic. I mean, these are very famous inorganic reactions, very famous inorganic inferences. I hope you remember this now, guys. Now, okay, perfect, great, everybody. Which brings us to the next one. Yeah, next question says, Again a JEE mains question. On treatment, a compound with warm dilute sulfuric acid, gas X is evolved. Okay sir, so I need to know what is gas X, which turns K2Cr27 acidified with H2SO4 green. Sir, this is the same thing. So what is Y? Sir, Y will be chromium. Sir, chromium. X will be sulfur, SO2 gas, not SO3. This I guess we have just discussed in the previous one. So again beta, see the same questions and they are repeatedly asked in JEE. So I hope everybody is getting why I am making you revise only certain specific but most important logics. Moving to the next one. Which one of the following complexes is volatile? Now beta, this is also, this is also there in GOC, the organic chemistry. Once you have that Lessagnase test, sodium nitroprusside, this is your nitroprusside group, which is FeCN5NO. This complex, whenever sees sulfur, so this NO which is in +1 state, this NO accepts that sulfide ion and forms NOS. So this ligand was having +1 charge, but with sulfur added, it will ultimately have a -1 charge. Hello. And this makes the solution in violet in color. So violet coloration also there in organic chemistry, also there in general organic chemistry. The first chapter, the first chapter of organic chemistry in class 11th. So this is also there in Lessagnase test. A very important conclusion. I hope you got this. Moving to the next one. Yes. Now, again a JEE mains question beta. A solution of CrO5, which is having your beautiful butterfly structure, the structure where you have 4 oxygen as peroxide, but beta, actually if you on standing this compound decomposes. If you want this compound to hold, this is a blue color compound, but if this only holds once you hold this compound. Sir, how to hold this compound? If you use some solvent like amyl chloride, then these amyl chloride oxygen as ligand, they ligate, they give their electrons to the empty orbital of chromium, and that's why hold chromium in this +6 oxidation state. So, and yes, once it is holded, it gives you its beautiful blue color. So I hope this inorganic knowledge also you are maintaining in your hard disk with the revision. But yes, now I am giving you, acha, I guess poll has stopped working beta. So no worries, no worries. Let us read the question first. Poll has stopped working. So let us read the question at least, because a very famous question again beta. Inorganic also, and Itard reaction also uses this reagent. So let us read it at least. The question says, when a mixture of solid NaCl, solid K2Cr27 is heated with concentrated sulfuric acid, orange red vapors are released. Sir, they are definitely CrO2Cl2. JEE mains asked it, JEE mains asked it, JEE advanced asked it, your NEET as is. Itard reaction also uses this to oxidize that methyl benzene to form corresponding aldehyde. So this is your famous reaction of chromyl chloride, those red color vapors. I hope everybody is getting these important inorganic facts. Moving to the next one. Now, when a solution of mixture having 2 inorganic salts was treated with freshly prepared sulfate in acidic medium, okay sir, a dark brown ring was formed. Sir, this dark brown ring is obviously because of nitrate ion, because we know that ferrous ions in acidic medium, once they react with any salt having nitrate ion, then ferrous ion, first of all, they oxidize to ferric ion, and nitrate ion gets reduced to NO, nitric oxide. But sir, no reaction is completely forward direction. So the remaining ferrous ion reacts with the produced NO and forms a brown ring complex. What is that brown ring complex? Sir, this Fe with this NO and water. How many waters are 5? this becomes your brown ring complex, and a complex is formed which can only be seen at the vicinity of the liquid junction of the because if you just tilt the test tube and you put that H2SO4 from the walls, as H2SO4 meet at the junction of the liquid, a brown ring is formed. So that means that that is definitely nitrate ion. These options are not having nitrate. Now let us go to the other option. Other one is saying, whereas on treatment with FeCl3, so who reacts with FeCl3 and form a deep red color? Sir, this is also classic acetate. Although you should remember this, sir, whenever we have ferric ion, then sir, this loves acetate ion and forms a deep red color complex. What is that exact complex? Sir, exact complex is you have at least 3 ferric ions giving +9 positive charge. Sir, you have 6 acetate ions giving -6, but I need more too. So this happens in basic medium. So you have 2 hydroxide ion, and this gives overall charge of +1. So this is the actual complex, but you can simply learn, you can also simply learn this as, sir, FeCH3COO whole thrice. But actual compound is this. Now, if you because of this, you find your red color, deep red color, which disappeared on boiling. If you just boil this substance, then on boiling it becomes a brown, or rather brownish red, but now it becomes a precipitate. That complex was soluble, but now this becomes a precipitate. And why it has turned into a precipitate? Because now this will just form this Fe hydroxide also and acetate also. But because this is +3, so this is 1 and these are 2 in number. So this is your PPT, and because of this you get a brownish red PPT. That means option 1 becomes your beautiful right answer. A very good knowledge of salt analysis, beta. I hope you are getting it. Guys, chalo. Anybody, any problem? Chalo. Moving to the next one. Acha. Before moving to the next one, beta, let me again, I have given this table. I have given you this table of cationic classification, because as you move down the group, value of KSP, we know there are some salts which are sparingly soluble. So if your value of KSP is increasing, that means your solubility is increasing. So those sparingly soluble salts also are arranged in order of increasing order of their solubility. Those who are very much less soluble are categorized in group 1, and then the group number is increasing. But yes, after group 6 we write a 0 group, where we have ammonium cation, which definitely has a more KSP value, but yes, again it's a sparingly soluble salt, so you get these cations as precipitates. Now how they are arranged, sir? Because we know they are sparingly soluble, so we have categorized them, that what type of salts they generally precipitate as. So first they are precipitated as chlorides, and therefore group reagent is dilute HCl. Who are these cations? So these are these cations. Their name is mercurous ion, Pb+2 and Ag+, silver ion. They are precipitated as chlorides, but if you have PbCl2, then PbCl2 is a precipitate only in cold condition. If you just heat the water, PbCl2 gets dissolved. A very famous point. I hope everybody is with me on this. Sir, please, what please, beta? I don't know. Yaar, okay. I only learned one sentence from them. Okay, chalo. So, any problem, guys? Shall we move forward? Guys? Yes, sir. Okay, perfect. Chalo. Cool. Sir, please. What Karan, beta? I have specially stopped. I want everybody to at least read this slide by the time I am reading some comments. The previous sentence means, okay. Sir, please repeat. What, beta? What do you want me to repeat? IU. Should I make? Chalo. I'm just stopping for a minute, beta, because I want everybody to digest this, because yes, I understand most of you are not comfortable with salt analysis, and that's why I picked it, because beta, NTA knows it. So if they know it, then you should not do it. You should at least work, and that is what I'm intending to do with today's live. Yes, Karan, you should. Yes, Karan, you should. Making that book, which will obviously at least write whatever mistakes you are repeating, if not all. Chalo. Perfect. Chalo. Let us quickly. Chalo, beta. I hope people are done. Now, let us quickly. I hope you have seen. I have given you this list of cations, detection, the group reagents in the inorganic live as well. But again, I know we cannot learn in one go. So again, revising it. So again, in dilute medium, if you pass H2S gas, then you are surpassing H2S will allow in acidic medium some sulfides are precipitated. So yes, they are termed as group 2 cations, but they are further divided as group 2A and group 2B, where group 2A constitutes mercuric, Pb plus 2, bismuth, copper and cadmium. Group 2B consists arsenic, antimony and tin, both plus 2 and plus 4. So for group 3, now in basic medium, you add, now in basic medium, so how basic medium? By using ammonium hydroxide, a very mild base, and use ammonium chloride. So that means I am using a basic buffer. So in this basic buffer, sir, what is done? Beta hydroxides are precipitated. So third group, so sir, trick, third group, so cations with plus 3 states. So what are them? Ferric, chromium plus 3 and aluminium plus 3. Now, if no PPT, then pass H2S gas, but this time in basic medium. So in basic medium, what metal forms PPT as sulfides? Sir, those 3D series, not all, cobalt, nickel, manganese and zinc, they are precipitated as sulfides. Now, fifth group, now you don't have acidic and basic medium, rather do you take ammonium carbonate in mild basic medium, which is ammonium hydroxide only. Sir, what are precipitated? Alkaline earth metals, not all, but barium, strontium and calcium cations are precipitated as carbonates, because you have used ammonium carbonate. And for sixth group, which consists of magnesium plus 2 largely, but yes, K plus and Na plus are also segregated here, because they are also precipitated, but no reagent beta, because you directly know this is the final group, so this will be the cation, so you directly do the confirmation test. But yes, there is one zero group also which has more larger value of KSP, therefore I have written that at the bottom. Again, no reagent as such, group reagent, because it also contains specially ammonium cation, and for ammonium cation detection we use Nestler's reagent, which is nothing but K2HgI4. We again do that in mild basic medium of ammonium hydroxide, and we get a brown PPT of iodide of Millen's base with this composition. I hope you can see the composition as well. Very important table beta. And if you learn this, let us check how many questions you can make. The first one, giving you 45 seconds for this. Why? Because I want you to digest what all logic I have communicated to you. Please digest beta. Quick. Please digest whatever logics I have given to you. Please digest. By the time I just get my water bottle filled again. Don't hold water. Hold water. Hold.
Hi sir, you've come from PW?
Yes ma'am.
Okay, your subject?
Chemistry. I'm live. Chalo, done. Answers? Yes, I have got my water bottle filled, or it is just getting filled. As I said, I am in a different location. So, see, sometimes you even have to search for water. So, I have gone to search for water. The search has been cleared. So, now I will get some water in I guess. Okay, I got water. Chalo. So, answer for the question. Acha, let me just confirm. Yes, it is A. So 84%. Now that means you guys have read that table. So perfect. Obviously FE plus 3, because you can obviously see it is talking about group 4. So which does not belong to group 4. So rather sir, it is 3. So it belongs to group 3. So perfect. But yes, I hope you have got that confidence. Sir, if you learn, then beta confidence is a byproduct. So again, a direct question on the application of what we have read. So please attempt this one as well, guys. Quick. Quick. Chalo, people are answering. Delhi. Yes. If you have attempted it properly, if you have just read 71%. So fair enough, beta. We have got many serious kids over here. So good. Sir, PB plus 2 and copper plus 2. So PB plus 2 and copper plus 2, sir, it is definitely first. Why? Because in acidic medium, if you pass H2S gas, they were precipitated as sulfides. Sir, what about these plus 3? So plus 3 is definitely that third group reagent, which is definitely in basic medium. You use ammonium chloride, they will be precipitated in form of their hydroxides. So, sir, what about cobalt plus 2? Sir, they are 3D series elements, and these 3D series elements will be precipitated by H2S, but in basic medium, sir. Sir, the basic alkaline earth metals, beta, they will be dealt with ammonium carbonate and will be precipitated in form of their carbonates. So, I hope, see beta, these all are mains question. Now, you tell me what confidence you should have once you read properly, and what heartbreak you should have if you leave such questions in your examination. A high probable question from salt analysis, beta, please remember. Please learn here only, because you can do it. Good. Perfect, Anupama. Perfect. So Edids is also giving answer. Let me read the question. The question says, passing H2S gas into a mixture of Mn, nickel, copper and Hg plus 2 ions in acidic medium precipitates. Okay. So after passing H2S gas into mixture of these ions in acidic medium, you are supposed to tell me which gets precipitates. Sir, copper sulfide and mercury sulfide, yes sir, they were actually group 2 reagent, group 2 cations which were getting precipitated as sulfides in acidic medium. So yes sir, obviously option 1 is our answer. So I guess a very doable one, 86%, fair enough beta. Moving to the next one. Quick, giving 30 seconds for this as well. Quick. Sir, formula, okay, this doesn't even require 30 seconds beta. This is formula of Nessler's reagent, which is K2HgI4 as an option 3. So you must have not attempted, but I guess this is what we have seen just now in that table. So see, it will be a crime not to attempt such questions. Now, the reaction of this lead nitrate and NaCl in water produce a precipitate that dissolves upon adding HCl. Okay, if you add it in appropriate concentration, the dissolution of the precipitate is due to the formation of. Okay, first it has formed PPT and then it has dissolved. Sir, first PPT will be formed because of PbCl2. We know it is a PPT, but yes sir, it is only a PPT in cold condition. And once even if you heat, it dissolves. But now we are adding more of it. Sir, lead has empty orbitals, so it can accommodate the further Cl minus, and sir, it can form a complex. But sir, Kashi Gaye Shankar PB, that means sir, inert perfect. So what oxidation state of lead will be most famous? But sir, it only happens for Kashi Gaye Shankar PB, as in it is the last element. So for it, sir, inert perfect will be most applicable. So lead will want to stay in +2 oxidation state. So let us search for a complex, a soluble complex where lead is in +2. Sir, here lead is in +2, here it is in +4. So option 3 is your right answer because lead wants to be in. So again sir, logic also, predictability also, and facts also. So you can either do by whatever sense. I hope everybody is clear with this, guys. Yes, perfecto. People, you people are rocking today. Next, sir, acidic ferric chloride solution on treatment with excess of potassium ferrocyanide. So I have ferric ion and I am taking potassium ferrocyanide as in K4 FeCN6. Now beta, this is a good inorganic knowledge which you should have. What sir? Beta, if you are taking them in, let's say, 1:1 ratio, or rather it is not mentioned, that means both are reacted, then beta, you definitely get a PPT. That PPT is your basic. Sir, what basic? Actually, that is also your next question. Sir, what basic, sir? Beta, this is your basic, as in you get Fe 4 FeCN6. Why? Because this Fe plus 3 gives you a Prussian blue PPT. This is also an NCERT logic, beta. What Prussian blue PPT, sir? This is beta, here Fe is in +3 oxidation state. And what about this? This is -4. That means x minus 6 equals -4. So this is +2. So what is this, sir? This is simple ferri, because Fe in +3 oxidation state. Ferro, because inside it is +2 oxidation state, cyanide. So very famous compound called ferriferrocyanide having a Prussian blue PPT is formed when, sir, once ratio is limited. So what is formed, sir? Ferriferrocyanide. That we know in the next question. Again, archive question. Now the thing is, if you just try to take this guy, but if this guy is taken in excess, like mentioned in this question, then what happens, beta? Because this is in excess, so potassium ions are large in number. So these K plus ion do not leave the complex, and this K plus ion attaches itself, and therefore a colloidal solution is formed. What is formed? Sir, a colloidal solution is formed. A colloidal species is formed which is having a Prussian blue coloration. So a colloidal solution having Prussian blue coloration is formed. Why? Because these potassium ions are not allowing the complex to have a category of a true solution, and rather it forms a colloidal solution, and these potassium ions act as those electrolytes which try to, because that was a, okay, not true solution, that was a PPT. So if I am attracted towards a PPT, so these potassium ions which are there in the solution, which will get adsorbed on the PPT and will break the PPT into a colloidal solution. A very important and great logic. So what it will, sir, that means you pick a compound which has K plus ion. So just check, this Fe is ferric, this potassium is +1, so +4 charge the cations having. That means that it is having -4. That means this is nothing but ethene plus 2 oxidation states. So beautifully, yes, yes, predictability exists, and definitely you should know such reactions, then only you should be able to do them. But I hope you are able to do them now. With this, let us move to the next one. Again, a beautiful question. Please, not giving you poll for this one, but yes, you have to draw organic structure also. So please try and attempt this one, guys. Quick, quick, everybody. Quick, quick. Quick. Nahi beta, not out of syllabus beta. These questions we are discussing from salt analysis only. Don't you have coordination compound in your syllabus? Because beta, RE-NEET, obviously because it's a RE-NEET, so is it happening all the time? So beta, you have to walk an extra mile. Because if such question comes, which is directly pre-YQs only, then you will feel bad that you could have walked an extra mile. So rather, with this session, I'm forcing you to walk that. At least you can learn these concepts with these questions, because these facts, lacks of fact you will not read, but some specific highly frequent facts you can, and this is what I'm intending to do. Yes, 14 is the answer, guys. Perfecto. Yes. Yes, perfect. Yes, let's see why. Let's see why. Sir, we know Ni plus 2. Technically, it should form. Sir, DMG is not a strong field ligand. So, technically, it should form tetrahedral. But, sir, if I have this nitrogen ligating, this nitrogen also ligating, this nitrogen also ligating, this nitrogen also ligating, and if somebody forces the complete molecule to be in same plane, then it will become rather square planar. And what is forcing? Sir, this is O minus. Sir, this is OH. Then, sir, this is O minus and this is OH. So, the attraction force of hydrogen bonding happening between this minus and this plus, and rather this minus and this plus, is creating a high intramolecular hydrogen bonding. Sir, but what it is? Beta, this is dimethyl glyoxime. Sir, I can't see it. Beta, this is OH. In basic medium, this one guy has lost electron, so this is 1 O minus. The another ligand has lost 1 electron, so this is another O minus. But where is the remaining structure? Beta, this nitrogen will be double bonded, this is glyoxal. So, what is glyoxal? So, this dimethyl, so CH3 and CH3. So, this would have formed an oxime. Yes, sir. So, that means this will be having double bonded, this will be N and OH. So, this N is definitely double bonded with a C. Rather, let me write that double bond like this. So, it is double bonded with a C, which is single bonded with another C, and which is also double bonded, and it is having methyl and it is also having methyl. So, this is H3. So, let me write that H3 with different pen because we have to count that. Similarly, sir, here double bonded C, it is attached, and C and C. So, let us count these number of hydrogens, sir. Beta, this will have 3 hydrogen, this will have 3 hydrogen, so 6. So 3 and 3, that means 6 into 2 is 12, and this one guy, sir, 13, and this one guy, sir, 14, because this guy has lost and this guy has lost. So how many number of hydrogens I have? 14. Also, sir, very famous logic. So again, this is asked, so this is nothing but DMG with glyoxime. which forms a bright red PPT. So why I'm only taking those factual logics, coordination compounds, inorganic chemistry, salt analysis, everything you can say. But beta, all these logics which I've told you have not came once. They have multiple occurrence. And because they have multiple occurrence, so deserve your attention. I hope you got it. Moving to the next one, guys. Starting, continuing with one more logic. So, okay, let us read the question at least for 30 seconds. Because yes, I want you to invest a bit of your attention on the theory. A bit, not more, but yes, 30 seconds I am giving so that you can at least read, and then we'll decide whether, sir, this is more, sir. No, beta, this is optimum. Rosy red, yes, Ashraf. Edits is saying C. Perfect. Anupama is saying C. Seja is saying 3. Chalo, people are answering 3. So poll has also ended. Let us check. 87%. So cool. Sir, why? Because in aqua regia, who dissolves, sir? Sir, in aqua regia, cobalt can definitely dissolve. So you have to find the compound A. So what is that compound A, sir? Cobalt sulfide dissolves in aqua regia. What is aqua regia? 3 parts of HCl and 1 part of HNO3. Sir, this gets dissolved, and once this cobalt has dissolved, so this soluble complex further reacts with nitrite ion in basic medium, followed by mild acidification with acetic acid, creating a yellow PPT. This creates a yellow PPT, and that yellow PPT, that color is because of this cobalt sulfide. Therefore, definitely, yes. Let me educate you. Acha, let me just check, beta, because in fact, even I am missing something for this reaction. Yes, the thing that I'm missing, the thing that I was missing is, let me include that thing, because yes, a good inorganic logic, beta, when this cobalt sulfide is reacting with your aqua regia, then actually what is happening, it is getting soluble because of formation of cobalt chloride, and this sulfur is precipitated in form of elemental sulfur. Point number 1. Now, sir, what about who is doing this? Sir, the aqua regia, which is 3 parts of HCl and 1 part of HNO3, that nitrate ion is transforming itself to nitric oxide, and obviously after this water. Sir, what else? Now, beta, this cobalt, which is in +2 oxidation state, this cobalt is actually reacting with nitrate ion, potassium nitrate, in fact potassium nitrite. Good reaction. This is happening in mild acidic condition. So this is happening in presence of acetic acid. And what this is supposed to form, sir? It is forming K3, potassium 3, because the complex is having +3 oxidation state. What, sir? Then you have a cobalt with nitrite ion with coordination number 6 as the complex, forming NO gas, creating the potassium salt of acetic acid and definitely water. Now, what is creating that yellow PPT, beta? This cobalt nitrite is creating that yellow PPT. Now, beta, again, I must tell you a good question, but yes, because this is latest JEE mains, latest question, that's why I have given you, but yes, rather, sir, then still, this is above syllabus, beta. This is property of cobalt. 3D series properties is valid for us. And because this cobalt sulfide property is elaborated over here, this AR is nothing but aqua regia. So, Yes, rather a good question, but yes, a good logic, but yes. If I completely understand you cannot learn all the logic, but whatever high probable logic, recent logics we have, I hope you can invest a few amount of attention to them. Moving to the next one. Chalo, attempt this one, beta. Now this is a, sir, you have left magnesium plus 2, there is no group reagent because you do direct confirmation test for magnesium plus 2. What it is, in basic medium, you use disodium hydrogen phosphate and this creates a white crystalline PPT. That PPT is directly because of formation of this magnesium ammonium phosphate, and therefore obviously option 1 becomes your right answer, which is a direct confirmation test for magnesium plus 2. And moving to this very important topic, beta. Sir, in this class you are doing only good things, yes. Because inorganic session I have already taken in the previous session. So with this class, I want to walk an extra mile with all of you. One more basic, JTD, John Taylor distortion. One more topic, which is JTD, known as John Taylor distortion. Now, what is this John Taylor distortion? Please understand. So technically what we see the octahedral complexes. Those octahedral complexes, beta, once some scientists have seen those octahedral complexes were not perfect octahedron having 90-degree mutual angles. No. These octahedrons once formed by complexes were distorted. The angles were not perfect 90-degree. Scientists were, you read them in your theory, but that is a theoretical point. Practically, whatever octahedron of complexes you see, they are having some distortion in their structure. They are not having perfect mutually 90-degree angles. Who decided this, sir? Who has seen this, sir? Scientist named John Taylor, and it is termed as John Taylor distortion. In general, it is termed as JTD. Okay, sir. Why does it happen, sir? Let us explore with basic, very easy, but yet very technical. Let us explore all the D configurations first. Okay, sir, let us do it. Let's say I have only one electron in D subshell. Okay, sir. Now, sir, if you are forming an octahedron, then the splitting will be T2G and EG. Okay. One electron going here. Okay. Now you tell me, do these electrons have same? I have 3 orbitals, but in those 3 orbitals of lower energy, I have unsymmetry. There is no symmetry. Sir, octahedron is supposed to be a symmetrical structure. So there has to be symmetry among the electron distribution also. Do you see symmetry here? No, sir. I should have either fully filled, half filled. Sir, this is not even half filled. This is T2G configuration of lower energy. That is EG configuration of higher energy. So unsymmetry exists, and it exists where? But sir, in the lower energy level. So what the scientist community, but yes, the primary force of that scientist community was the scientist named John Taylor, and he said, he observed those complexes which are having metal ion in D1 configuration, but in D1 configuration, whatever they were also not having perfect octahedron, but the imperfection was very weak. So the distortion was very weak. So he said weak JTD distortion. Sir, D2 is also partially filled configuration, partially filled T2G. So this will also have weak John Taylor distortion. So this was also not perfect octahedron. No. Once you have D3 configuration, sir, D3 will have half filled configuration, sir, in the lower energy T2G set. Yes. So a perfect crystal. So whenever the D block metal ion has D3 configuration, it will have perfect octahedron in nature also, where all bond length will be equal. So there you have your green color perfect octahedron. Everybody clear till here or not? Just hit the comment section. Please tell yaar. Physical chemistry, please. Beta for physical, Ankush for physical and physical chemistry. I have separately done beta more than 2 sessions for physical chemistry. I have included. So yes, after the NEET examination, just go to all the lives of chemistry of me in PW NEET English channel. Beta, they will be helping you like anything. But yes, you have to read. So I can't read for you. You have to read for yourself. So please do that. I hope you got it. Acha, chalo. People are clear. Chalo. Ashraf, Edids, Revan, unknown, everybody. So let me sip water also, beta. Let me sip water also. Now. But not okay. Now, come on. Now, sir, that means D3 configuration was having perfector. Move forward, sir. Enjoying, sir. Bring metal ions making octahedral complexes with metal ion having D4 configuration. Sir, now problem will come. Why? Because now you are entering in heavy energy orbital. Sir, heavy energy, more energy, sir, with less stability, sir. I will bring, sir, I'm having energy, I will bring punches around. Sir, distortion will happen. How? Sir, if it is weak field ligand, then the electron will occupy Eg, because weak field ligand, so this energy gap is very less. So this will be T2G3 Eg1. So T2G is symmetrical, but now Eg has become unsymmetrical, sir. Eg is heavy energy, sir. Heavy energy subshell, sir. So this electron has created more energy, sir. More distortion, sir. So with strong field, this is with weak field ligand. So with weak field ligand, you have strong distortion, red color, strong JTD, but with what? Weak field ligand. Sir, why no ligand compared over there? Because beta, you were not having electrons, so there was not a question of getting on the top or pairing from D4, you have that. So doing that. Sir, but if strong field ligand, then I can't occupy this. Then I will be forced to pair. Sir, this is this is again partially filled. But beta, which is partially filled? Lower energy state. Distortion will be there, but again distortion will be weakly distorted. So in strong field ligands, such cations, such metal cations will be weakly distorted, but in weak field ligand, you will have strong distortions of octahedron. Clear. Beta, till 12. Hassan, till 12 I will be going. Maybe 11:30, around 11:30. See, so I want one thing from all you people. Yes. 9. Okay, this is 9:50 now. So around 12 we'll be going, beta. Chalo, good. Shall I move forward, guys? Chalo, good. Beta, I need confirmation in the comment section. Okay, it's Hasni. Okay, I'm sorry, Hasni. Hasni, beta, we'll be finishing around, we'll be taking, let's say 10 minutes break also, because 10 minutes break, hai na? So 10 minutes break we'll be taking, and then we'll be coming back, and then we'll be finishing around 11:30 max, 11:30, 12, hai na? Chalo. Kunal sir, thank you, sir. Kunal sir, thank you. Okay, chalo. Shall we start? I hope we are clear till here, guys. Chalo. Best sir you are. Okay, beta. Beta, let us read. This is good concept. Please let us read. Now, the only reason I stopped was because with D4 configuration, you should have strong or weak, you should know. At least now if you are clear, then you can predict by yourself whether the octahedron that you are forming is weakly distorted or strongly distorted. Beta, I am telling you, nobody teaches it. Nobody knows. So please, I'm not saying everybody knows, but please let us be specific about the content, because this is good. Now, sir, talking about D5, sir, okay, sir. Now, sir, we know, sir, we can do common sense, sir. 3 and 2, sir. Because, sir, weak field ligand, so fifth one will also go. Sir, now this is half filled, so stable T2G. Sir, half filled, stable EG also, sir. So, sir, that means with weak field ligand, I will have perfect octahedron, no GTD, no John Taylor distortion. But with strong field ligand, sir, with strong field ligand, again, I cannot reach up. So, I will be forced to fill at the bottom. So, I will again be having partially filled configuration, but partially at lower energy level. So, I will have distortion, but that will be weak, because where I am having that partial electronic configuration, sir, in the lower energy T2G set. I hope everybody is clear. Let me show this. It is just getting hidden because of this. So, see, this is partially filled. So, in strong field ligand, I have weak JTD. In weak field ligand, in presence of weak field ligand, I have no JTD. So, what does no JTD means? Perfect octahedron. I hope everybody got it. I hope everybody got it. Guys, chalo. Moving forward. Now, sir, moving forward, okay, sir. Now what we have, let's say D6 configuration. Sir, now we can do it. So, 1, 2, 3, 4, 5, and then 6th will be filled here. Sir, 1, 2, 3, 4, 5, 6, because this is strong field. Sir, so in presence of strong field, it is perfect, sir. Sir, that is also perfect, sir. So, strong field will again have no JTD as in perfect octahedron. But weak field, sir, above energy level is symmetric, sir. Sir, this is unsymmetric, sir. So, it will, because of above, you are good to go. But they will say not good to go, although weak, but they will have weak JTD. It will have a distortion, but what distortion, sir? Weak John Taylor distortion. Now, sir, D7 configuration. Again, sir, this is symmetrical, this is unsymmetrical. So, with weak field, weak JTD. Sir, this is symmetrical, but now high energy has become unsymmetrical. So, because high energy EG is unsymmetrical, now, sir, I will have distortion and strongly distortion. So, strong JTD. Sir, this is symmetrical, this is also symmetrical. So, with weak field ligand, no JTD, perfect octahedron. So, symmetrical. So, with strong also perfect octahedron. So, this is a case actually which is D8 configuration. D8 configuration, you have any type of ligand, this always have a perfect octahedron, and this was a luck that initially when the scientists were doing spectroscopy, they were finding perfect octahedrons and no distorted octahedrons, because they were only luckily working on those metal cations which are having D8 configuration. And because D8 will have no effect, D8 configuration will always form an octahedron which is beautifully, all bond lengths are equal. All bond angles are 90 degree. I hope everybody got it. Guys, chalo, moving forward. Now, sir, D9 configuration, sir, again, sir, this T2G is symmetric, but EG is unsymmetric, sir. Oh my God. High energy level EG unsymmetric. That means, sir, with weak field ligand, strong JTD. Sir, this is also not visible now. See, sir, this is symmetrical. So now this is again, sir, EG not symmetrical. So strong JTD, whatever ligand is. So again, if I have a D9 configuration, then also it doesn't even matter whether ligand is weak or strong. My octahedron is not going to have same bond length. It is bound to have unequal bond length, and because JTD distortion is large enough. I hope everybody is clear. Perfect. Now, sir, if octahedron is distorted, that means what? Bond length are not equal. Because in octahedron, you feel bond lengths are equal. They are not. Especially once ligands are approached along z-axis, once you observe them practically, they are either elongated, this bond length along z-axis is either elongated or it is compressed. Sir, if it is elongated, what does this mean? This means that the incoming ligand has not approached closer. That means, sir, its repulsion will be less. That means whatever d orbitals you will be having participation of z, they will be having less energy, because along z nobody has approached. Nobody has approached to a closer extent. Sir, if I will come, then I will increase your energy. Na? I have not came to your place. I have just called, hey, I will be coming. Or rather, I am there in the neighborhood. So that means along z-axis, I am not feeling that much of repulsion, that much of energy. So all the orbitals which are having z component will be less energized. Here, when compression, that means the ligands have approached inside, energy is increased. So in this case, orbitals having z component will be having highly energized. Sir, come over here. We definitely know this is T2G and this is EG, but sir, we know through square planar complexes, they also split. But now I am not going to square planar complex. I am talking even before and more than that. Sir, if along Z, people have come to a lesser extent, then energy of Z will be less. So out of dx2y2 and dz square, energy of z square will be less. Out of dxy, dyz and dzx, wherever I have z, see, xz also has z, yz also has z. So they have less energy. Why? Because along z axis, there is elongation, as in ligand has approached to a lesser extent. So energy is less, so energy reduced. And rather, if there is case of compression, that means along z people have approached, ligands have approached, sir, so they have created more energy. So z is more energized. So z square is up among EG set. Z orbitals are up among EG set, among T2G set as well. So this defines beta your John-Taylor distortion. And a beautiful question explaining John-Taylor distortion is this. Like for example, if you are asked, if copper H2O6 having +2 charge is having elongated bonds, that means bonds are elongated. So bonds are elongated, as in ligands has not approached along Z, that means Z has lesser energy. Then the unpaired electrons lies where? So Z has lesser energy, so Z is lower. How many electrons we have, sir? Cobalt in +2, that is 3d9. So 1, 2, 3, 4, 5, 6, 7, 8. 9th electron is present, my dear friends, in dx2y2. dx2y2, again, a very good logic. Again, a very common, yes, not common, but if you are attempting for your RE-NEET examination, knowledge of such 1-2 extra points is going to make the difference. I hope everybody got it. Guys, chalo, perfect. Please revise this once and I hope you will be clear. Which brings us to the last lap for today's live, which is carbonyl compounds, aldehyde, ketones and carboxylic acids and their derivatives. The organic chapter, which most of the students feel fearful because it is having loads of reaction. Even NCERT is filled with reactions. So yes, yes, theory not good. Okay, hi everyone, hi Priya. Okay, chalo. Now again we have switched to learning the logic as in attempting questions and then learning all the relevant NCERT. So starting, yes, I guess, come on. So I guess we can start the process of aldehydes, ketones and carboxylic acid with this question, and the time I'm giving is 30 seconds so that I can also have some water and you guys can also attempt. Quick beta, quick. A, everybody saying A. न्यूमेरिकल्स अच्छे होते हैं. चलो परफेक्ट. चलो. Yes, 100%. So perfect, a very doable question, beta, because yes, isopropyl alcohol is, iso group is this, OH is this. Once you oxidize it, you will get a ketone. Moving forward, let us read and attempt this one, my dear students. Quick. Quick. Now, beta, we can do pretty fast. So, no worries. We can finish pretty fast because we have reached the last lap for today's live, which is discussion of aldehyde, ketone and carboxylic acid. I guess within 1 hour we'll finish, beta. Yes. B. Okay. So let's see. Answer is definitely Bombay. Why I have specially 30%? So why I know what will be, I know what doubt you will be having. Sir, in NCERT only copper is given. But beta, you can obviously understand copper, silver, gold are same period elements. They have same property. Yes, not always, but yes, for this you can obviously understand that whenever you have an alcohol, then heated copper acts as a dehydrogenating agent, and it removes hydrogen and undergoes oxidation. So here also you will, from alcohol you will form, because this is 2-degree alcohol, so you will form a ketone. If it is a 1-degree alcohol, you should form an aldehyde. If it is a 3-degree alcohol, then you can do dehydration. Just like heated copper, you can take silver also. So yes, this confuses few students, and this is the same reason because of which I have brought this question. So beta, please be mindful of this. I am bringing all the questions with deep thoughts, deep analysis. So I hope you are enjoying them. These are not just random questions. I am bringing with some idea around each question. Perfect. All alkenes of molecular formula this on ozonolysis gives 2,2-dimethyl-propanol and okay, an alkene. So you have to tell what the alkene is. So obviously, I guess most of the students are saying A. So let us see how many of you have got A as an answer. So poll not working, I guess. Now 40%. Yes, percentage is less. So let us discuss this now. An alkene of molecular formula this. Sir, leave it. No. Why? Sir, do direct opposite thing. What opposite, beta? I have an alkene. On ozolysis, it is giving, sir, write the products. So propane as in 3 carbon, 2,2-dimethyl as in this, and then propanol, that is double bonded O. So this is my first compound. What about other? Sir, butane 2-one. So but as in 4 carbon, and second carbon is having double bond. Sir, ozonolysis, that means, sir, combine them. Okay, beta. Let us combine them. So this is 4 carbon, sir. This carbon is combined with, double bonded with this carbon, and it is having this group. Sir, ozonolysis of this, if you will do, you will get that. Now you are supposed to give the IUPAC name of alkene. So this is my alkene. So what will be its IUPAC name, sir? Beta, this should be in the main chain. So I can go here also, there also, but yes, here I will be going in this direction. So I am at one end, and over there I can go anywhere. So let us select the main chain. Numbering will be starting from there because multiple bond is closer. Branches are also more. 1, 2, 3, 4, 5, 6. So how many branches I am having? 3 methyl. So it is having 2, 2 dimethyl, 2, 2 and 4. 2,2,4 trimethyl, and after that hex 3-ene. That means option A is definitely your right answer. I hope you got it. A very practical question, but yes, a very doable and a very probable question for your RE-NEET exam. And yes, after that, let us revise NCERT with this question. So we have space, so let us do the question here only. Quick guys, quick. Now, again a JEE Mains question which is asking you, I have acid chloride. Sir, this is also classic, sir. Hydrogenation. Palladium, because you need hydrogenation to take place, so you need a catalyst. But sir, I do not want alcohol, so I want to stop at carbonyl state, therefore I will poison the catalyst. So this is nothing but Rosenmund reduction, a classic case where you use Rosenmund reduction and convert acid chloride to form corresponding aldehyde. I hope everybody is 92%. I expected 100, but still let us revise NCERT. That means this is going to help everybody. Time starts in 3, 2, 1, go. Quick. The question again says the major product of the following reaction. Sir, this is a nitrile, sir. Sir, Stephen reduction. Nitrile with SN, it's SnCl2 plus HCl gives you imine, and after hydrolysis it gives you aldehyde. But sir, you can also use dibyl H. What is dibyl H? Diisobutyl aluminum hydride. Post hydrolysis, it converts ester also, it converts nitrile also to corresponding aldehyde. So sir, aldehyde is our answer, sir. You can stop the poll, sir. We know NCERT, sir. 37% know NCERT, so bad. That's why I'm making you revise NCERT also. Moving to next question. Try and attempt this one, guys. Time starts in 3, 2, 1, go. I am having space, so actually there is one profit here. My board is 75 inches. This is big, so I can keep this, but I have a habit of putting it over there. You must have heard, no? If you have scarcity of something, even if you get ample of something, you still feel you have scarce of those resources. So just a joke for me. I hope you will not understand. So just a joke for myself. Chalo, people are answering. Okay, B, C. Okay, B, C. Chalo, check. I guess B is my answer, beta. Acha, poll hasn't stopped. Now it has stopped. 23%. I guess answer is B only. Huh, beta, please. What happened to you guys? Beta, NCERT not revised or what? Please revise NCERT. Make sure. Let us. I am making you revise only. I am making you read. I am making you learn all the reactions with questions, with probable questions. Now, this is NEET 2025, not J1 JE. Identify suitable reagent for the following conversions. Okay, sir. Let us do it, sir. This is ester, sir. Sir, aldehyde. Sir, you just now said ester can also be reduced by, sir, dibyl H followed by hydrolysis. So this we have recently done in the previous slide. Nitriles also and ester also. Nitriles can also be reduced with tin SnCl2 as in with Stephen reduction, but yes, dibyl H can reduce ester also and obviously nitriles also. So I hope everybody is clear, beta. Moving to next one. Time starts in 3, 2, 1, go. Quick. Now, quick everybody. Perfect. I'm buffering or what? Hello? Chalo. Am I buffering? Chalo. I hope time is done. So let us check the question. Sir, this is also Okay, let me just check, beta. Excuse me.
Sir.
Buffering from there. I hope I'm clearly audible, beta. The screen was buffering. Now it is good. Now it is good. Just put the screen on my side. Is it buffering? It was. Guys, am I clear? No buffering. Okay. Okay. No buffering. No. Perfect. No. It's good. It's good. See, this is coming. That's why I felt so. Although students are not facing any doubt, so it's okay. Chalo, no buffering. Okay, perfect, guys. Perfect. I mean, in my screen it was so. Okay, chalo, cool. Now, sir, this is also a classic NCERT reaction, sir. What is that, sir? Let us first check 50%. So that means I have to make you revise, sir. What happens is, if you have a methyl benzene, then this is your beautiful inorganic compound CrO2Cl2. So in presence of CS2, it first creates an intermediate complex. What is that intermediate complex, sir? Sir, benzene, that benzylic carbon makes two free valencies with what? With, sir, oxygen. This oxygen, one oxygen has bonded itself and it is still having a chromium complex, and this chromium complex is now having, sir, one H gone. Sir, where gone? Another oxygen would have taken that H. So this becomes OH and two chlorines. So this is nothing but OCrOHCl2. Sir, OCrOHCl2. But how many, sir? One more. So CrOHCl2. So this intermediate is formed, and post hydrolysis, sir, what will happen? Beta, hydrolysis will break the bond. Sir, oxygen will get O minus will get plus, plus will get minus, or rather you can break the bond from this side also. Anyway, it will get H plus. Those guys will get OH minus. Sir, one carbon having two OH, as in geminal diols are unstable. So in order to stabilize, they will dehydrate. So once dehydration takes place, you get your corresponding aldehyde. Sir, this is nothing but Itard reaction. That means, sir, this is my intermediate. That means, sir, I can move forward. And again, sir, methyl benzene. Okay, this will be CH3. It's a printing mistake, sir. With Cl2, you can have monochlorination also at the allylic position. Di also, tri also. But here at water with around 100 degree, 90 degrees Celsius, 190 degree, I mean heated water, you get hydrolysis and you produce your corresponding aldehyde if you have formed this dihydric, as in if allylic substitution happens two times. So this is one Cl, another Cl. Sir, you already told us once Cl is replaced by OH, then diols are unstable, and in order to stabilize, dehydration take place, and what is formed, sir? This you already told, corresponding carbonyl group, which is a benzaldehyde. That means I have no, sir, not one acid chloride, no, not one chlorine, because one chlorine will give us benzyl alcohol, but this is aldehyde, so incorrect. Yes, sir. B will be our answer, because 2 chlorine will give 2 OH, not an acid, because 3 chlorine will give 3 OH. I hope everybody is clear. Guys, moving to the next one. Yes, attempt this one in 3, 2, 1, go. Quick, beta, quick. Again, a very famous question to make you revise the naming reactions. Ask him to not put 25 degree, because it was 25 degrees Celsius, I guess. Ask him to make 20, because he has again turned 25. It is heated. Chalo. Perfect, guys. Perfect. Perfecto. D. Now, I guess this is with the revisions that we had, with the revisions of naming reactions. Yes. So, productivity is increasing. Obviously, answer is definitely Delhi, because this is what we have recently revised. So, moving forward with the next one. Time starts in 3, 2, 1, go. Quick. Quick, everyone, quick. Quick, everybody, quick. Quick. Yes. Perfect. Chalo. Now, after this question, we'll have a 10 minutes break, beta. After this, we'll have a 10 minutes break and then we'll again restart. Okay. Because even I have to go for some bio breaks. So, we'll have a 10 minutes break and then we'll come back. Hai na? Chalo. So, this will be, but yes, please don't go anywhere. I just need a practical bio break for 10 minutes and then we'll be continuing. We'll be finishing carbonyl compounds very properly. All those aldol, Kenny, Zaro reactions we'll be revising through relevant questions. I hope everybody is with me. So again, you also get up from your seats, have a 5 minutes, 7 minutes, 10 minutes break and then we'll again start. Chalo. The question says, now again these are latest JEE questions. Identify major product X formed in the following reaction, sir. Benzene with HOCO and HCl, sir, it will do formylation, as in it will act as a formyl chloride. So, sir, that means it will be, this carbon will be attached as carbon, benzylic carbon, and you will be forming your benzaldehyde. So, sir, this is what? This is also a naming reaction known as Getterman synthesis. Again, an NCERT fact. So, obviously, sir, where you see aldehyde, sir, beta, I see aldehyde as option C. So, let me see 100%, not less. I hope you have not revised your NCERT. So, I'm making you revise that NCERT as well. So, this is again basic NCERT reaction, beta. Acha, which moves to next question. But yes, you can attempt this one. Again, a preparation of ketone. But yes, for before this, beta, this is, I guess, time is 20 to 16. So, let us meet at 22 as in 10. Let us meet at 10:30 p.m. We'll again start at 10:30. A bio break for few minutes and then we'll be back. So maybe I'll be back before 10:30. But yes, so please come back, because with this, after this, we are going to discuss complete aldehyde, ketones and carboxylic acid chapters with complete relevant questions. Okay, so chalo, we'll meet it at 10:30. Sound mute. Yes, guys. So I hope everybody has taken their bio break, because definitely I have taken. I hope I am clearly visible and audible, everyone. Just put the comment screen towards me so that I can read my students. Just yes, yes, thank you. So yes, guys. So 2 minute, huh? So I hope I'm clearly audible, guys. Good evening again. Good evening, Muskan, sir. Okay, okay. We can't do that, Mr. Yadav. We can't probably do that, because if we do any of those things, then 21st is just near, beta. You can understand most of them must be doing that thing what you are saying. So we should not do it, so that we can create the difference. With that intention, I have brought topics also today, that to make difference, to create the difference between you and the remaining students, because the more you practice, and the precise and precision of selection of the content also, because you can't learn everything, but you can learn certain specified important things. With that, I have intended to design this lecture. Trust me, designing of what chapters, what questions I should take for this particular session, I have invested lots of efforts. Although I was indulged in many other activities still, because I want your result to outshine, because I want everybody to know that at PW NEET English we work, and we mean that we work. है ना? चलो, let's चलो. I want, हाँ, you want NEET class, beta? This is NEET class only, beta. Okay, okay, chalo, perfect. Now let's start. I hope I'm clearly audible, guys. Chalo, perfect. Moving forward now, sir. This is, I guess, this question you all have attempted, sir. See NCERT, sir. So we definitely know, sir. If we have dialkyl cadmium as an R2CD, let's say R-2, and it reacts with what compound, sir? It reacts with acid chloride, because this chlorine is a very beautiful leaving group. So this leaves, and rather whatever dialkyl group I am having as R dash is attached here, and this precisely forms a ketone. So in order to form your corresponding ketone, I definitely need an acid chloride, a very famous NCERT preparation of ketones. Moving to the next one. Time starts in 3, 2, 1, go. Hit it, beta. The major product of the following reaction is, sir, you are using Grignard reagent, sir. Carbonyl compound is having positivity here. So this plus, who will attract? A minus, sir. This is my electron rich species created by Grignard reagent. So first this will go, and this O minus will get Mg plus. After hydrolysis, it will get OH. That means, sir, it is an alcohol. Okay. So first thing, it is an alcohol, sir. This is also alcohol. Sir, this is also alcohol. No, sir. Obviously, this is also alcohol. So only one option eliminated. Now, sir, cyanide will also get this. So cyanide will also get this Cn minus. And after that, this triple bond will get double bonded. And sir, then after hydrolysis, this double bonded will get 2 OH. So it will get a carbonyl group. So methyl added and a carbonyl group. That means that is definitely a ketone. So my answer is beautifully option Bombay. 81%. So fair enough. I guess we did this question in our previous live, and I guess during that point of time, yes. But sometimes even you can have a different perception for a question. Like for example, sir, somebody can argue, sir, because this is an excess, this is an excess, so it can work again. But beta, yes, probably yes. But you tell me, after using, then you do hydrolysis, and after doing hydrolysis, you get this, no? So once you have hydrolyzed, now it is not there in excess, no, because you have cleared all this after hydrolysis. So probable it should be Bombay only. I hope everybody is clear, guys. Chalo. So people are back. Chalo, perfect. पोल का शो होता है बेटा, यू हैव टू डाउनलोड PyLens in order to access the polls. चलो, moving forward, let us attempt this one, guys. 3, 2, 1, go. Now the question says benzophenone. Sir, what is this benzophenone? Beta, this benzophenone is benzene ring having a carbonyl group and attached with a benzene ring, because I was not having space, so I rather drawn pH. Now, sir, benzoyl chloride reacting with benzene and AlCl3. Sir, this is nothing but benzylation. Sir, this will definitely create, sir, Friedel-Crafts acylation. In fact, benzylation. Sir, benzoyl chloride, sir, acid chloride with dialkyl cadmium, sir, this also creates ketones, sir. This will also create, that's why you have both A and B. So C will be your best answer. I hope this is a beautiful NCERT exemplar question, beta. So 80% perfect. So see, if you perform, if you read, if you respect NCERT well, this is going to happen to your actual NEET score. Quick guys, quick. Awesome. People are participating actively. I'm very happy for all you people. God bless my dear students. God bless NEET warriors. God bless future doctors. This is what you're showing. This is what exists in a great doctor, in a great aspirant, or rather a time pass one. Because 24 lakh people actually passes their time. The number of serious candidates are very less. I hope you are one of them. Chalo, perfect. Perfect, guys, perfect. Super awesome. Chalo. Now the question says, sir, time ended, beta. Let me see. I just wanted to see the percentage. Accordingly, I should decide how should I deliver. So yes, percentage is less, beta. So let me describe this. Which of the following arrangement with respect to reactivity in nucleophilic addition is correct? Now, beta, the logic is, if I have carbonyl group, then obviously this carbonyl group is having positivity is this carbon. First factor which decides the reactivity is electrical factor, electronic factor. Sir, the moment it is just hydrogen and not any other alkyl or any other group, sir, these alkyl groups create plus I, thereby decreasing positivity. Even if you have aromatic rings, sir, that is even horrible. Why? Because this is minus I, that means that is plus I. So, sir, positivity is getting reduced if you have either alkyl or aryl. In fact, aryl is even worse. That's why alkyl carbonyl groups are more reactive towards nucleophilic addition. Icing on the cake, icing for aldehyde, not for ketone, because aldehydes become more reactive because aldehyde have less steric hindrance also, but that is secondary. Primary is electronic factor. So because of electronic factor and steric factor, both aldehydes are more reactive. Among aliphatic and aromatic, sir, aliphatic are more reactive. Now, if you just know this common sense, attempt this. Sir, this is benzaldehyde. That means benzene ring, sir. C, double bond O, sir, H, but it is substituted with NO2 group and the para position. Sir, this is a minus R, but ultimately this carbonyl is a minus R group. So obviously aldehyde, that aldehyde, if you have any aliphatic aldehyde, it would be better. But I guess all the options are having aromatic carbonyl groups. So that is, if you have any aliphatic carbonyl compound, it will be best. But sir, everybody is aromatic, so let us compare. Because it is having minus R, so ultimately it will try to increase the positivity. Because it will try to increase, so this shall be more reactive, so this is good. What about benzaldehyde? So benzaldehyde will be simple aldehyde. No extra minus R, nothing. What about, sir, but this is even worse. Why? Because this aldehyde is now substituted, sir, with a electron donating CH3 methyl group, sir. So this will give electrons, so positivity will further be reduced. That's why less, sir. This is going good, sir. And what about last? Sir, last also, sir, you have this carbonyl group, sir, but it is saying acetophenone. So this is a ketone, sir. That means this is acetophenone. Sir, aldehyde is even more reactive. Ketone, sir, is worse. So that means this should be least because it is a ketone, that too aromatic ketone. So this will be least reactive. With that, I hope option A becomes your right answer, which less percentage, but yes, that's why I explained the complete question. Moving to the next one. Time starts. In 3, 2, 1, go. Quick. Yes, perfect. Perfect, guys. Perfect. People are answering. That's awesome. Good. Great. 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 Ketone least reactive. Yes, Muskan. Now, which among the following aldehyde is most reactive towards nucleophilic addition? Sir, you have already told us. This is also all our aldehydes, sir. The more plus R, or rather the plus I, sir, it will, although inductive and steric also, it will decrease. So simple aldehyde will be most reactive because inductive and steric factor will decrease the reactivity, sir. So I hope, I just wished it will be more, but 63%, I hope you got it, beta, because of electronic factor also and steric factor also. Aldehyde, simple aldehyde will be best for nucleophilic addition. Moving to the next one. Quick. Quick. हाँ, plus I लगेगा. Yes. Plus I लगेगा. Yes. Perfect. Good, good, very good. Why not C? Muskan is asking, why not C? Beta, this is having plus I, no? Plus I also and hindrance also. So obviously it will not be C. I hope you got it. Chalo. For this one, I hope people have got the answer. Beta, see. With HCN, what we have? Sir, this is ketone. Sir, this is example of nucleophilic addition. It will form cyanohydrin, sir. Cn minus will go here. Bond will move. And then, sir, O minus will get H plus. So first, sir, this will be formed, already given, sir. This is nothing but cyanohydrin, sir. Okay, beta. Sir, why you are revising, beta? Because obviously, I want to revise you, make you revise NCERT also, and then obviously solve the relevant questions also. Now, sir, concentrated sulfuric acid does two things. Sir, with alcohol, na, it do dehydration. That means alkene will be formed. Sir, but acid, it also do complete hydrolysis, sir. Partial hydrolysis of nitrile form amide, but complete forms acid, sir. So it should be acid also, and it should be having an unsaturation also. So can you find acid? Yes, sir, I can find acid. But sir, this is an unsaturation, and because this is carbonyl group, so this is alpha beta. That means this alkene is also conjugated. So Sidzev says you should form a most stable alkene. That means without any doubt, option A becomes your right answer. I hope everybody got it. 64%, but still fair enough, beta. I hope now everybody got it. Moving to the next one. Yes, try this one, beta. 3, 2, 1, go. Quick. Quick. Everybody. Quick, everyone. Unsaturated acid. Yes, alpha beta unsaturated. Yes, beta. Yes, Jhaji. आ रही है. Don't worry, Jhaji. Chalo, perfect. I hope people have attempted. Let me just check. 3, 2, 1, go. I hope less percentage. The reason I'm seeing the percentage first, beta, because I want to know how to keep the explanation. If you are attempting it, then obviously I'll keep it crisp. Else I will be knowing that you need explanation, and that's why I'm waiting for the poll. Hai na? Chalo, now. Sir, residue A and dilute HCl forms compound B. Now, what is this residue? Let us see the question then. It is saying I have toluene, that to excess of toluene. Sir, this is famous chromyl chloride, sir. That means this is ATAD reaction. So, this benzylic carbon will be turning into an aldehyde after hydrolysis. But it is not stopping at hydrolysis. That aldehyde is then reacted with sodium bisulfite. Sir, we know carbonyl compounds with sodium bisulfite forms addition product. So actually this after, yes sir, but addition product will be precipitated, sir. So you will filter out that precipitate. So this is my residue. My residue will be, sir, a bisulfite addition product, which is simply known as adduct of whom, sir? Beta of benzaldehyde. So this is my A. You are asked this A first. So this is not bisulfite addition product. This is not bisulfite addition product. This is not bisulfite. This is actually intermediate of ITAD reaction. So this is not asked. This is bisulfite addition. So with just option A, you can see, sir, this is aldehyde reacted with sulfur as a nucleophile, and this O minus of carbonyl will become OH. This is good, sir. But now what are you doing? Sir, we are reacting with dilute HCl, sir. We know these adduct, once you hydrolyze them even in acidic medium or basic medium, they form the parent carbonyl group. So it has again formed the aldehyde. That means definitely option 2. A very practical question, a direct implementation of NCERT beta and JEE Mains 2025 question. So you can obviously expect such healthy discussion of NCERT in your NEET examination as well. Moving to the next one. 3, 2, 1, go. Quick. Quick. Everybody, quick. Quick. Chalo, perfect. I hope you are getting it, beta. Sir, CH3I will first do this, double bond O will become O minus. Post hydrolysis, you are bound to attach this CH3 and this will become OH. That means, sir, it is alcohol. Sir, dehydration of this alcohol, this is my A, will definitely bring, dehydration will definitely bring an alkene, sir. So CH3 bond CH, double bond CH2. This is my B. Hydroboration oxidation, sir, it is anti-Markovnikov addition of water. That means this will be 3 carbon chain, but first carbon will have OH. Now you have to give relation between A and C. So this is a 2 degree alcohol, that is a 1 degree alcohol. That means they are position isomers, sir, because degree matters for amine, not for alcohols. So that means they are simply positional isomers, because if the degree changes, then for amines the property changes like anything, not for alcohol. So for alcohols it is rather just positional isomers. That means option Bombay. 64%, could be more, but I hope everybody got it now. Now this is the statement, and these are the statements based on this question. So let us first read the statements and then we'll decide whether they are true or false. Moving to the options, moving to the timer. Quick, beta. Quick. Everybody, quick. Read the question. Read the question. Nice and awesome job, everybody. सोनी झा, अरे कोई हिंदी में तो बोल लो बेटा. रीड द नेम ऑफ द चैनल, PW NEET English. So why we have written English? Beta, have that compassion. There are many people who are only and only comfortable. For the past 1 week, I am in southern side of India, and trust me, the level and the commitment which students have over here is awesome, and they cannot understand Hindi, beta. So there exist people, you have to be compassionate enough, guys. Chalo. Yes, I am from Kerala. I am in Kerala, John. Yes. Chalo. Time done. Let us check, beta. Acha, I have not given options, so I am sorry. Acha, I have not given options, beta. Actually, both are true. 90% fair, yaar. Very good. Chalo. I have showed options, so most of you must have cracked that through the options. Now, you have to consider this reaction, sir. It's a ketone, and on hydrolysis, it is forming a diol, gem diol. Obviously, I know this lone pair can attack here, this can move, and this O minus and this OH can be added. Okay, sir. The equilibrium constant for this reaction is given as capital K. Okay, sir. Statement 1 is saying in case of formaldehyde. Now, if it is not a ketone, rather formaldehyde, then this value of equilibrium constant is about this much times due to small substitution and faster hydration. Yes, sir. If it is K, I am not saying it is going forward or backward. It is saying it is happening and the value is K. We definitely know this reaction is largely shifted in backward direction, in this direction, because diols are unstable. They dehydrate and form ketone. We know that. But question is telling you it is happening with value K. It is telling you. Now, if it is aldehyde, so with ketone it is happening. So if it is an aldehyde, then sir, if it is happening, then with aldehyde, if it is happening with ketone, then in aldehyde it will happen more. Why? Sir, because aldehydes have more plus and less hindrance. So it is about this many times. Yes. So this is not incorrect. This is correct. I am again saying this does not mean diol is stable. Diol is unstable and it undergoes dehydration to form ketone. But question is saying if this is K, then for aldehyde that K should be large. Yes. Now, statement 2 is saying in case of trichloroacetaldehyde, which is this, whatever this K will be, if this is not an aldehyde, this is trichloroaldehyde, then K is again large, 2000 times. Why, sir? It is bulky, sir. I hope you remember that chloral thing from alkyl halides. Sir, if you replace this, sir, then once, let's say, OH attack and this double bond O becomes OH and OH, let me show you that. If water attacks and this become OH, so actually this carbon having OH, where you have carbon but having 3 chlorine, so these 3 chlorine will withdraw electrons, so positivity here also is very high. So attack will also be prominent, and on the contrary, sir, it will have intramolecular hydrogen bonding, which we should know from the concept of chloral. Hello. So a beautiful question, beta. A beautiful question. That means this is also true. That means both are true. Just JEE 2025 question, a very beautiful question to make you attempt, understand and learn the logic of carbonyl compounds. Moving to the next one. Time starts in 3, 2, 1. Go. Shoot, beta. Kindly read the question properly. I hope this you can make. Without any help. Quick. Chalo, A. Perfect. 88%. Let us check. The question says, beta, this is cyanohydrin you get once you react carbonyl compounds with HCN. Sir, acetal you get once you react carbonyl compounds with alcohol. This ester can be hemiester, it can be complete ester. So definitely, sir. Schiff's base, sir, Schiff's base once you react with 1-digramine, because that is alkyl, substituted, I mean, sorry, that is substituted, I mean. Sir, oxime you get once you react with hydroxylamine. So yes, again an NCERT basic beta. I hope I have made you revise that basic properly. Moving to the next one. Time starts in 3, 2, 1, go. Quick, 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 everybody, quick. Yes, perfect. Chalo, perfect. Chalo. The question says you have to identify the final product of the reaction sequence. So first I have this aldehyde, sir, with lithium aluminium hydride after hydrolysis. Sir, this will give H minus, will go to carbonyl group, and this will give H plus. That means, sir, this carbonyl group will be reduced to alcohol. So this will be CH3 CH2OH. Now, sir, acid dehydrating agent, sir, so it will give you alkene. HBr, sir, it will form you alkyl bromide. Sir, sodium, sir, alkyl bromide and aryl bromide, sir, sodium, sir, Wood's reaction, Wood's Fittig, sir. So benzene will get this ethyl group. So this is simple, sir, Bombay, sir. So again, a beautiful sequential question. 30%. People are saying A. I don't know why. I hope everybody is clear now. Beta, this is again, this is NEET 2023. So you have to make yourself aware of practicing NCERT. I hope everybody is clear. Guys, chalo, perfect. Next. Attempt beta, 3, 2, 1, go. Quick. Quick. The product P is formed in the following reaction sequence. Acha, here you just have two options. I guess two options are misprinted, not written. So just okay, 50-50. So sir, this is zinc, amalgam and HCl. That means this is nothing but Clemmensen reduction. Sir, Clemmensen reduction reduces carbonyl compound to corresponding alkanes. But yes sir, only carbonyl compounds. So this will be turned to CH2. Sir, this is ester, so it will not react. This is also carbonyl group, sir. This will also be reduced. So this will become CH2. So this guy will become, already I have one H, so this will become CH3. But yes, ester will remain as it is. So Bombay will be your answer. Perfect. So see, there were no C and D option, but these 5.88% students they are gem. There are only two options. Still they have selected C. Hats off. Moving to the next one. Bombay. Quick. Now again, I guess this is quite doable one beta. Still I have given poll. Sir, this is ester turning to aldehyde. So ester can turn aldehyde with dibyl H. So this is again ketone turning to an alkane. That means I need a reducing agent. That means this will be Clemmensen or either Wolff-Kishner. So because Wolff-Kishner is hydrazine in basic medium followed by boiling in ethylene glycol, not given. So this only. Sir, aldehyde getting reduced to alcohol. That means okay. Carbon is also increasing. So CH3 is getting added. Okay. So I need Grignard reagent. That means this is one. And definitely this leaves me with this is ketone and this is ester. But I just want to reduce ketone, not ester. That means I need selective reducing agent, which is nothing but sodium borohydride, which only reduces carbonyl compound as an aldehyde and ketone to 1 degree or 2 degree alcohol, not any other functional group. Yes, technically it reduces acid chlorides also, but not famous for NEET level of question. But I hope you learn that. So this gives Bombay as our right answer. With 60% students have attempted it correctly. Moving to the next one. Quick. Now the question says I have A. as my product. So this is beta again. Now this is nothing but Wolff-Kishner reduction, which I was saying. You react with hydrazine. So this is again addition, elimination, nucleophilic addition. Then after elimination, you get your corresponding compound. And after ethylene glycol, you further process in basic medium and you get your alkane. But yes, this reaction happens in basic medium. So how many, sir? I have 4 carbons, so this will be reduced, and 4 carbon alkane is definitely Bombay. So again, a doable question. So Bombay, still beta percentage is less. Why people are answering D beta? Because followed by, this will be only reacting with hydrazine. If it is only reacting hydrazine, then this is the product. But post hydrolysis beta, post hydrolysis, this guy will get a hydrogen. And also in over here beta 1, 2, 3, even carbon number is not same. This will also a 4-member chain. Yes, maybe I guess that's a misprint, but if at all it is, even this question is not at all possible, it is 3-membered. So still people have answered, so I hope everybody is clear. People have answered Delhi more, that's why I'm saying so. Yes. Coming to another famous reagent, which is Tollens reagent. Now what does Tollens reagent tell us? Okay, little mistake. No worries, no worries. Sir, I'm little scared to give RE-NEET. Beta, don't be. In fact, trust yourself and practice hard. Maybe it is whatever has happened is best for everybody. I do not know. Yes, obviously those who have religiously and disciplined and sincerely studied and got good marks also, but still it happened. So beta, we should be always positive about the future, because whatever has happened is inevitable. So rather be constructive about whatever universe is doing to us, because whatever is happening is inevitable. Can you criticize it and change it? I'm not talking about the demography. Yes, you can, because that is how a democracy should work. But by nature, what is happening is inevitable. Yes, you can modulate the customization of humans, which we will definitely, that's why we work and we do it. But yes, try to be open, try to be positive. That is what we can do and we are doing. Chalo. Moving forward, yes, people are answering. So let us check. I guess answer is A. Again, a very, yes, actually people are answered C. You know why you have answered C? Because answer is definitely C. But this is what NTA can also do. Answer is definitely C, because who can give Tollens test? Sir, Tollens test can be given by all aldehydes, either aliphatic or aromatic. Sir, ketones you already said gives very less nucleophilic addition, so do not. Sir, only Tollens aldehydes gives this. No. There are many reagents, but yes, few of the famous for your NEET examination are, sir, hemiacetal. What is a hemiacetal? Let's say if I have a carbonyl group and it is reacted by an alcohol, sir, it forms a hemiacetal. Why? Technically, you first protonate by adding H+, then this creates a positivity, but I am just making you the logic. I am just giving you the logic. So this will come, oxygen will take electron from hydrogen, so this becomes your hemiacetal, as in this double bonded O becomes O minus and this becomes OR. This is my hemiacetal. This hemiacetal beta, why? Because sir, this is also a very weakly moved forward product of aldehyde. So this also easily converts back. This hemiacetal easily converts back. How, sir? You just introduce it with some water and that water easily hydrolyzes this. Why? Because that will be added, and the moment it is added, it is left, it is removed in form of RO minus. That H plus makes ROH, and one carbon having 2H dehydrates and form carbonyl group. So actually hemiacetal are also practically carbonyl, as in aldehydes only. So they also give positive Tollens test. And I hope you can see that, sir, I need a carbon and an OR, as in this is ether, and with this carbon you should have OH. Sir, with this carbon I am having OH and this is a hemiacetal group. That's why C will definitely give you Tollens test. Agreed, sir. One more famous thing is alpha hydroxy ketones. Like for example, if I have this ketone or carbonyl group, and its alpha position, alpha as in the carbon next to this carbon, is having hydroxy. So they also give positive tolerance test, although it may be a ketone, but still it will give positive tolerance test because there are some structural identifications also. Also, there are many other compound structures which can give positive tolerance test, but for your NEET examination, these two you should know. That means our answer is C, but C option is B. In fact, A option is C. So this is how they have manipulated options also. So I hope everybody got it. Chalo, perfect. Chalo, moving to the next one. Time starts in 3, 2, 1. Go. Shoot, beta. Everybody. Quick. Nice, nice, good. Aditya, Edids, Shining Star, Muskan Preet Kaur, Dubey ji. Acha, Dubey ji, okay. Aditya, chalo, perfect. Let me check. P is an optically active compound. Okay, let us solve this and then we will check, because anyway I will be solving this. So question is, P is an optically active compound with molecular formula this. When P is treated with 2,4-DNP, it gives positive test. That means it is definitely having a carbonyl group. However, P in presence of tolerance reagent gives a negative test. Okay, P is not giving tolerance test. That means the tolerance test is given by aldehydes, aliphatic, aromatic both. Felling test is given by only aliphatic aldehydes, because copper is even a weaker agent. Copper is even a weaker agent than silver. Silver is tolerance test. Tolerance test reagent is silver salt. Copper salt is the sodium potassium titrate that you use as Rochelle salt to hold that copper plus 2 ions from cupric sulfate. Because copper plus 2 is relatively lesser reactive, so it can only react with more reactive aldehyde, which is aliphatic. Hence, Felling test is not given by aromatic aldehydes. I hope everybody is with me on this. Now, the NCERT revision, not as Felling, still telling you. Now, sir, because it is giving negative tolerance test, that means this is definitely not an aldehyde. That means this is definitely a ketone. Because carbonyl it should have, because it is giving positive DNP. I hope this much is clear. Now we have to predict P. Sir, this is ketone. Yes, it can be your answer. This is ketone. Yes, it can be your answer. This is ketone. Yes, it can be your answer. This is aldehyde, sir, cancelled. So first thing from there. Now, sir, it should have chiral carbon. Let us check chiral carbon. Sir, here there is no chiral, so this is gone. Sir, here both methyl, so there is no chiral. Beta, see, you do not have to move your pen. Common sense if there is with you. These are JEE questions, and I just hope I have good percentage here. Arre baapre. People have answered D. Very bad, beta. I hope everybody is clear. Guys. So, guys, I need confirmation. Everyone. Chalo, perfect. Moving to next one. Attempt this one, beta. Again, I guess this is quite doable question, so we'll do it together. See, hydrazine and KOH. Sir, hydrazine and KOH is nothing but Wolff-Kishner reduction. This is tolerance reagent. That means this is one. Now, the reason I'm just telling you this is because reagent I have to make you understand. Felling solution A is copper sulfate solution. Felling solution B is sodium potassium tartrate, also known as Rochelle salt. So this is my Felling's reagent, Felling solution A and B. Zinc amalgam and HCl is Clemmensen reduction. So obviously, I guess you are getting D as your answer. Less percentage, but still I feel people are getting it now. Moving to the next one. Now let us solve this together. The question says the compound which gives positive filling test. So this is aldehyde. Sir, only aliphatic aldehyde gives, sir. Aromatic, sir, do not give, sir. Sir, this is ketone. Forget it, sir. Yes, sir. This is ketone, but at alpha position, it is having OH here also, here also. So because this is alpha hydroxy carbonyl compound, that's why this will give you the test. So C is definitely correct. Now, sir, this is aldehyde, aliphatic aldehyde, this can also do. Sir, this is aromatic. No, beta, this is not aromatic because this carbonyl group is connected with this benzylic carbon, which is sp3 hybridized. So many people make this incorrection. This is not aromatic aldehyde. This is aliphatic because carbonyl group is connected with an sp3 hybridized carbon. So this will also give, that means C, D and E, that means Bombay is our right answer. I hope everybody got it. Moving to the next one. Let us attempt this one, giving you 30 seconds to attempt this. Quick, beta. Quick everyone. Perfect. Perfect. Chalo. The question says an optically active alkyl bromide. Okay, sir. So it is optically active and this is your bromide. Reacts with alcoholic KOH to form major compound A. So, sir, if C4H9 is optically active, so let us rather search those optically active structures because this is easy to do. Sir, 4 carbon, as in these are 4 carbons, and I have bromine. Then hydrogen will be 3 to 5. 5 plus 2 is 7. 7 plus 2 is 9. Sir, this is having no unsaturation also. I always suggest don't remember those DU formulas. Rather just make a structure and then satisfy it and you will see it is having no unsaturation. Is it optically active? No, sir. Is this optically active? Yes, sir. Because this carbon is having methyl, ethyl, bromine and hydrogen. So why bother of thinking about any else? Let us work on this only. So this is my alkyl bromide. Now alcoholic KOH. So alcoholic KOH, sir, this is also beta, this is also beta, but that will be more stable alkene. So I will be forming this more stable alkene. Let's say this is A, which is my major product. Now this reacts with bromine to give B. Sir, it will be vicinal dibromide, sir. So this is my compound B. Compound B reacts with alcoholic KOH and sodamide to give C. Sir, this is alcoholic KOH and sodamide, sir, alkyne will be produced. But because this is here only, so alkyne will also be produced here only because they will be removed. Here H, one HX gone, another HX gone. So this will not be terminal alkyne, rather non-terminal one. So this is C, sir. After this C, one molecule of water adds to compound C on warming with mercuric sulfate and the sulfuric acid to form compound D. Now, sir, if you just add one molecule only, but in presence of H2SO4 and HgSO4, that means that this is hydration of alkyne. Sir, it will add water. Because it is symmetrical, so OH and H. So we definitely know, sir, the triple bond will become single. So this is OH and this is H, and we definitely know after this what happens? Sir, tautomerization. So this will tautomerize. What is that, sir? Beta tautomerization. The double bond will come here, hydrogen will move there. So this will give you a carbonyl compound. So sir, 4 carbon and this carbon will be having double bonded O. What is this, sir? This is D. The functional group in compound D will be, sir, it is ketone. Okay, but this will confirm what? Ah, sir, hello form. Why? Because beta, it is having CH3. What is hello form test, sir? Beta, it is also an oxidizing agent. It only oxidizes methyl ketones like this, methyl ketones. This CH3 is removed in form of hello form, and this carbon is oxidized, and because it happens in basic medium, so rather we report this carbonyl group as carboxylic acid salt, sodium salt, potassium salt, whatever it is. So ultimately, which test it will show? Sir, it will show positive tolerance test. So let me check. 33%, but yes, a very beautiful question, beta. I mean, not old beta. This is JEE Mains 2026 April question. So I hope you are getting the idea where NTA has got its major attention. Chalo, quick, guys, quick, everybody, quick. Yes, Kucherov reaction. Yes, Arpit. हाँ बेटा. Yes beta, it was actually lengthy, but beta, this is what we should, which we mean by when we say you should walk an extra mile, because walking an extra mile will obviously require energy beta, no doubt. Sir, I can't. Sir ji, I don't have the courage to write it again, sir. Shining star, you have to work for yourself, beta. सर आप डेली ये सेशन लेते हैं क्या बेटा? यश, इफ यू आर फाइंडिंग इट, if you are beneficial, then beta, as teachers we only exist for you, so we will. But yes, not daily, but yes, we have physics, biology, chemistry, all sessions. So every day you get at least one. Chalo, perfect. I hope people have got the answer. Now let us check. Iodoform, okay sir. Sir, methanol is CH3OH. No, I am nothing doing, sir. Sir, ethanol is CH3CH2OH. Yes. So this alcohol can get oxidized, and after that it will be having a, sir, because haloform oxidizes a ketone, and ketone are supposed to be not easily oxidized. But if anybody is capable of oxidizing a ketone, that means it's a strong oxidizing agent. So it will first oxidize alcohol to carbonyl group, and then methyl group is having, so it will be giving haloform or iodoform test. So this can be distinguished. So this is acid and this is acid. Acid is not supposed to give haloform, so cancel. Yes, acid is generally not the one. So cyclohexene, cyclohexanone. So this is a ketone but not having methyl group, so this will not give, so they can also not be distinguished. Sir, diethyl ether, so ETOET. And then pentane 3O. No sir, pentane 3 as in here. So no sir, no methyl group, so this can none can give. Anisole is benzene having OCH3. Okay, it can't give. Ha sir, acetone can, sir. Acetone is having methyl group, sir. Okay, so this can give and this will not give, so they will be detected. So E is also an answer. So A and E can be distinguished. So A and E as an option C will be our answer. Let us check. Beta, percentage is less, but I hope after the discussion it is helping students. Moving to the next one, because this is an integer type question, so not giving you any poll but solving. Let us solve together. X is the product which is obtained from benzene by reacting it with carbon monoxide and hydrogen chloride. So sir, carbon monoxide as in CO, hydrogen chloride as in HCl in presence of cuprous chloride as in Cu2Cl2. Sir, this is nothing but Gattermann reaction. So with benzene, this must be producing benzaldehyde. So Y, so X is benzaldehyde. Sir, X is benzaldehyde. What is Y? Y is the major product obtained from benzene by reacting with ethanoyl chloride in presence of anhydrous AnCl3. Sir, this is Friedel-Crafts acylation, sir, acid chloride, sir. So Y will be benzene reacting with acid chloride will be inducing this carbonyl group C double bond O, but ethyl as in through 2 carbons. Product major obtained by X and Y in the presence of, okay, now they are treated with alkali. Sir, that means now we have came down to aldol condensation, because if you have carbonyl compound and that carbonyl compound is having alpha carbon, then that alpha carbon behaves as an acid and rather creates a minus. Once this carbon creates a minus, this attacks the carbonyl group. Double bond O becomes O minus. After acidification, you get H plus, but after that you do dehydration. So it is a carbonyl group, this is alpha. So rather simply remove 2 hydrogen of this and that oxygen and combine them to get alpha beta unsaturated ketone. Sir, that means you are saying it is benzene. Sir, this is carbonyl group. Whatever alpha carbon you have, you take that alpha carbon and do not think anything, directly add double bond. 2 hydrogen of this, 1 oxygen of carbonyl group, gone. So this is CH and benzene. This is how you can get your alpha beta unsaturated product easily in a line. Now what is said, you have to calculate pi bonds. Sir, benzene has 3 pi bonds. This has 3 pi bonds. 3, 3, 6, 7, 8. Total pi bonds are 8. But the question is asking pi, number of pi electrons, not bond. 90% of the student will doing this also wrong. So it will be 8 into 2. So answer will be 16. I hope everybody got it. Moving to the next one. Quick attempt this one, beta. Quick attempt this one. Quick. Yes, 16. Arpit. Robin Yadav is here. मैंने लाइक नहीं किया आज, यश और किसी ने किया होगा ध्यान से. हाँ बेटा, लाइक. Even I have not liked. Let me also like. सर मेरे 12th में बहुत कम मार्क हैं जिसके कारण गवर्नमेंट नहीं मिल रहा. हाँ बेटा, these things will hamper या बेटा. These will है नहीं बेटा. See, you have to hold your confidence high beta. These all are situations and they will definitely pass. Just keep yourself going in life. That is what is expected out of you. Chalo, let us discuss beta. Again, a good question. You should approach such questions. How, sir? P is a hydrocarbon of molecular formula C8H14. Okay, sir, 8 carbons I have. Okay. On ozonolysis, P forms Q. Q on treatment with alkali under reflux condition produces R, which on treatment with I2 and NaOH gives yellow PPT. That means it is giving iodoform test. Acidification of solution gives S. Okay, that means after acidification, CH3 must be gone and you must have got sodium salt of corresponding carboxylic acid. So acidification will give you the perfect carboxylic acid. And S structure is given, sir. Okay, then let us move backwards, sir. This is my carboxylic acid. So the sodium salt will be COONA, sir. It will be formed how? Sir, it will be formed when haloform is done. That means it will be having methyl. So first, it is not oxidized, so make it ketone. So we are going backwards. How backwards, sir? Beta, I am saying this will be formed. Sir, how this will be formed? Beta, this will be formed after haloform reaction. Sir, whose haloform you will do? Beta, first make it ketone. Sir, carbon will not change. Okay, beta. So this is 5-member ring. Sir, this is also double bond. This is also CH3, sir. This carbonyl group will not be an acid, it will be a carbonyl group, and rather it will be having a methyl group, sir, because this methyl will be removed and here this will oxidize. Okay, I am getting it, sir. That means, sir, this is produces R. So, sir, this is R, sir, because this was S and this was sodium salt of that S. Hello? Now, this R is produced from Q. This R is produced from Q. You did what with Q? Q was treated with alkali. Okay, so I have treated this with an alkali and then this guy has formed. So, after ozonolysis, I have treated with alkali. That means, sir, this has been produced from a carbonyl compound. And what this compound is, I hope you can see, this compound is alpha beta. So this is carbonyl, so this is alpha beta. Acha, sir, this is alpha beta unsaturated. That means it just has formed through aldol. And sir, you have taught us how to think of that aldol product directly. So think opposite, how to think what I have taught you. So this is alpha, so alpha will lose hydrogen and beta will lose oxygen. Remember alpha, hydrogen and beta. So add them, sir. Okay, beta. So this is my carbon, who will be getting CH2. So this is my carbon, CH2, having C double bonded O and CH3, sir. Why CH2? Because this is always also connected with this carbon, connected with this carbon, connected with this carbon, then this, then CH3, and this carbon has recently received double bond O. Sir, you are moving backwards. Yes, beta. So this is my P. No, not P, Q. Because Q on treatment with alkali is giving R. Now you tell me how you have obtained this Q. Rather, how you have obtained this Q, you tell me from here. Like this. How you have obtained this Q? So this I have obtained by ozonolysis. So ozonolysis of that has been done. That means add them. You will be getting your alkene. How many carbons? Let us see. Let us number those carbons so that to form a beautiful picture. So this is 1, 2, 3, 4, 5 and 6th carbon. So 1 and 6 will meet, sir. And 1 and 6 are also having methyl group, sir. So 1, 2, 3, 4, 5, 6. 1 and 6 will meet, sir. And 1 and 6 are having methyl group also, sir. No other group. That means, sir, this is my answer. This is my P. Beautiful question. Beautiful question. Beta, I'm giving you few questions for practice as well. Yes, I am giving you. Everybody got it? Chalo. So these are the few questions. Again, very beautiful questions. But these are a few questions which I am giving you for practice. You can obviously see them. Sir, where to find these questions? They are very beautiful questions, sir. We want to attempt them. Yes, beta, even I want you to attempt them very properly. But yes, I want you to attempt them properly first, and therefore I have given you around 12 to 15 questions for practice. And if you do that and if you find any problem, actually you will not find if you have been consistent with the session. But if you do that, I am telling you, you will be getting that extra amount of confidence, and with that confidence, you will be doing great. Yes, if you have any doubt, then we will be definitely meeting in the next live. And in that next live, you can ask all those doubts, or rather, after this live is done, just go to the comment section and whatever doubts you have put that over there, I will always be looking at those comments to give you the best possible solution. Now, With this is Gaurav Singh Arora signing off. But sir, where we will find these notes, just go to PW NEET English WhatsApp channel right after this. I will be sending these notes over there. You can download these notes and practice these questions back at home. So I hope you are doing best utilization of the time. And with that, I will meet you soon. All the very best, guys. Bye-bye.